and welcome to the FME Server 2017 authoring course. So this is the first time that we are delivering the training course for FME Server 2017. If many of you have been using 2016.1 and previous, this is a great opportunity to check out some of the new features in FME Server 2017.0. So on the GoToWebinar control panel, you'll notice that there is a button to raise your hand as well as a chat window. If you have any questions during the session, you can type them out, and myself, Rylan Masjack, should have introduced myself. I'm on the FME Server support team. I have Laura sitting next to me. Hi, Laura.
Hello.
So we're ready today to talk FME Server all day, every day, for the duration of this week. Of course, 2-hour sessions. So if you have any questions, please type it out in that chat window. Laura or myself will attend to them ASAP. And then we'll be asking some questions throughout. If you click the put your hand up button, then we can get an indication, such as right now. How many people, by show of hands, have used FME Server before? So it looks like we've got 1, 2, 3, 4, 5, 6 hands. Okay, so we have a few of you who are using FME Server 2016 or older. Maybe you're on 2017. Maybe you're doing a little leg up. You want to learn some new features, perhaps some items that you don't cover in your daily workflows. The rest of you, it looks like, are going to learn a lot today, which is fantastic. So we'll just start off with some of the administration items. On each of your desktops, you'll notice I'm working on a virtual training machine exactly like you. On the desktop here is a link for the FME Server course resources. That should bring up a page for on our Knowledge Center here, where you can navigate to our 2017 training manual. If you open that link, you're brought to Gitbook, where you can either choose to download a PDF, or if you have a tablet or e-reader, there are other formats available for you. I'm just going to be working directly off the web browser, so I'm going to click this big green read button. So this is the training course manual as it will be presented. You might, for the keen person, notice that we have the current status of this manual is incomplete and should not be used for training. We can safely ignore that. We are in a training course right now. The manual is just going through some final review, and it will be fully complete for our partners and resellers to deliver as well shortly. But we at Safe Software are giving ourselves the okay to deliver. If you've attended any of the FME Server training courses before, you might be more familiar with the 4-hour, 2-day format. This is now a 2-hour, 5-day format. So we will be spending 2 hours in each of the main sections. That is the introduction to FME Server. We have split up the self-serve with FME Server into 2 days, 2 parts. Real time with FME Server, and we'll finish up with the new feature in FME Server 2017, projects. So this here is just a page about this document. It is an introductory level training course. We do assume some prior knowledge with FME Desktop. I believe we cover that in the course overview here. So we do assume some basic familiarity with the concepts and practices of FME Desktop. If you do find yourself falling behind in any of the exercises, we do have complete workspaces available for you to use. As well, all of these training machines will be up 24 hours a day, all week. So if you'd like to work on them after the course, before the course, in your own time, at home, right before bed, you have the option to do so. So on this training computer, we have installed FME Desktop 2017 and FME Server. There's also a PostGIS database, Tomcat, and one of the later versions of the Java virtual machine. All of the resources for this course are available, installed already to the hard drive on the C. FME Data 2017 will have all of the source data and workspaces that we will be interacting with today. So before we get started, I'll just ask one more question here. How many people have not used FME Desktop or FME Server before? All right, thank you for that. That just gives a great indication for the pace to deliver this course. So let's kick it off. Introduction to FME Server. So FME Desktop, that is where you develop your workflows, your data translation, your spatial data translations. And FME Server is the enterprise product where we can run these workspaces in response to external events. We can set up automated workflows, and we can also have this idea of self-serve capabilities. So those are the three core capabilities of FME Server. Self-serve, such as providing an end user the availability to select and download data that they require in the format and structure. The self-serve is an excellent capability because it actually can fully remove the whole concept of FME to the end user, and they just need to upload a file, click a button, and then everything can run in the background unbeknownst to them, and then they just get the results that they require. The real-time capability, this aspect of FME Server, allows you to carry out workflows or set up workflows to respond to real-time events, messages or notifications or streaming data, allowing you to have the most up-to-date information. And then automation. This is covering schedules through the FME Server web user interface, and as well through other devices, syncing your workflows between them. So just at the bottom here, we do note that FME Server is not the authoring tool. That is FME Desktop. To actually create workspaces, you have to use FME Desktop. You have to have that installed and licensed. FME Server is kind of the central repository where we can all publish and push our workspaces to and have them run up there, have them run on a centralized machine, not necessarily our laptop computers. So in FME Server, we will be talking of a few roles today, and just so that I can ensure we're all on the same terminology here, we have this handy page to outline that. So in terms of FME Server, we have the concept of an author. That is someone who's going to be creating these data translations, these workspaces with FME Desktop. They're going to be publishing them up to FME Server, and they're going to have probably a very good understanding of FME Desktop and Workbench functionality, and will be able to debug their own workspace. We also have the FME Server user, and this is just an end user who might have limited knowledge of FME, if at all, and they just interact with FME as a service to provide them their data translation needs. So the example we give here is a user, someone like a CAD operator checking out spatial data, or a business manager looking into their corporate data in the FME Server web UI and a dashboard or something. We also have the concept of a developer. FME Server is compatible with a lot of web development. So if you want to create your own custom forms, custom pages, you can utilize the FME Server REST API. And that's something that we would envision to be this developer role, like a web dev. And then there's the administrator role in FME Server. And you can see a variety of tasks here, such as planning, installing, licensing, setting up, as well as monitoring the health of FME Server and providing some general troubleshooting. Now, we'll do a little plug here. We have an FME Server Administrators course, which was presented for the very first time at the recent user conference in Vancouver. Was anyone here in Vancouver, by show of hands, attending the FME user conference? So just by looking here, oh, we have a couple here. That's great. So glad that you were able to make the journey to Vancouver. So most of the training course today will be presented as if we're all FME Server authors. While we will touch on some of the administration tasks, the focus is on the authoring aspect. So for this particular diagram, we're not going to dive in too deep, but we will do a general overview of this FME Server architecture. So we do have this client server model that's depicted in this diagram here. We have our web app server sitting here serving the user interface, the REST API, all these web services that we'll get into. We also have other clients here that connect to FME Server via the REST API, so that's Workbench, Server Console, as well as custom applications. Now the meat and bones of FME Server is right here in this bottom diagram. We have the FME Server core, which manages the workspaces, your jobs, which is a job is how we refer to a running workspace, for example. Also our notifications, repository, and also a onboard software load balancer. And we will get into the details of these a bit more. But we have the core here. The core has a file system, much similar to what we have here in this data folder, as well as we have FME Server connecting to a database. The default database for FME Server in an installation is Postgres, but we also support connecting to Oracle and Microsoft SQL Server. The FME engines is what will run your translation. And notably here, we have 1, 2, 3, ... all the way up to N. So if you're running FME Desktop, you're essentially sitting on one FME engine. The advantage with FME Server is we can actually scale out and add additional engines to process workflows in parallel. Also shipping with FME Server is built-in fault tolerance through a process monitor application. This ensures that your subscribers, your publishers, your scheduler, everything is healthy when your FME Server core is up. So here we go, FME Server engines process your job requests. Each FME engine processes a single request at a time. So that's why we'll see our FME Server installations have multiple engines, so we can run multiple workspaces at the same time. FME Server Core is what manages and distributes those job requests. It also manages the repository contents and everything related to notifications, which we'll get into later this week. Now, I did mention the web services of FME Server. So this is a list of what we refer to as these services. This is your data download. So this is a translation that will run on FME Server and will provide you a link to the data that was requested. We also have a data upload service, getting data into FME Server. Data streaming, which we'll look into later this week. The most popular job submitter, which is kind of like clicking the run button on FME Desktop. It's just a simple translation run. And then we have a variety of other services here, all of which we'll touch on later this week, with the exception of a few of these which are a little bit more on the administration side, such as token security and REST. You'll notice at the bottom of many of these pages, we have these questions that you can answer for yourself. All of the questions have answers at the end of each chapter. So you can use this training manual as a resource in all of your future FME server endeavors, and you can refer to these questions as kind of little tips. So a little bit about deploying FME Server. It can be deployed on a variety of platforms. We currently have installers for Windows, both the 32 and 64-bit architecture, as well as Linux platforms supporting Ubuntu 14, 16, and Red Hat. For anyone familiar with Docker, we do also have a technology preview of FME Server on Docker. So for all those Mac OS users out there who have a little bit of Docker experience, yes, you can get FME Server running on your Mac computer. We can install FME Server, whether it be on physical hardware, or virtual hardware, like these Amazon EC2 machines we have running right now. And also, we mentioned here, platform as a service such as FME Cloud. FME Cloud is a special case of FME Server where we manage the installation and health of FME Server, and you just interact with the web user interface, and it runs on this pay-as-you-go basis. If you're interested in FME Cloud, I encourage you to check out our Knowledge Center at knowledge.safe.com. We have some great articles as well as some blog articles about FME Cloud. If you want to get fancy with your FME Server installation, we do support distributed environments. We recognize that a lot of our customers do have their applications and services spread amongst various instances or machines for fault tolerance and in the event of disaster. So 3-tier is our distributed model. We have the presentation tier, which is the web app server powering the FME Server web UI. We have this application tier where you're actually running your FME Server core and engines. And then we have this data tier where we have our file system and database. One thing to note here is the core and engines can also be separate from each other on different machines. We have many customers who have dedicated FME engines on very powerful computers for processing large point cloud data, large raster data. As well, you can mix and match your platforms of FME engine with your server core, so you can have Linux core connected to Windows engines. You could have 32-bit engines, 64-bit engines. There are lots of different configurations possible. And if you're interested in learning more about this deployment model and FME server architecture, the FME server administration course, once we have that up and running, will be an excellent opportunity for you to learn more. So I did mention that FME server requires FME Workbench to create the workspaces. FME Workbench has the ability to transfer or to publish workspaces up, and that is where we will be running them. We'll be doing this quite a lot in this course, and you'll gain a lot of experience there. So a little bit on repositories. Workspaces are stored on FME Server in a repository. The repository is located on your Windows file system or Linux file system where you've installed your FME Server core. And so when you're publishing a workspace from your local computer up to FME Server, we actually publish a copy of that workspace up. I believe that's an important concept to be aware of. So we always have a copy of that workspace in FME Server. So if you publish it from one computer, you can go to another computer, grab that workspace, update your workspace maybe, and republish it back to FME Server. So you always have the latest version available there. The repository doesn't hold just your workspaces, but can also hold supporting source data sets and other supporting files for workspaces such as custom transformers, formats. You can publish up templates there. So it is this kind of big open container where we can publish all of our files. So transferring workspaces from FME Workbench to FME Server. We have a wizard here, a publish wizard. So when we open up this wizard by selecting it under the file menu or the publish menu, and I'm going to open up FME Workbench here so I can show you. Wait for my Windows search load here, FME Workbench. Go Windows 10. These are Windows Server 2016 instances, so if you haven't worked with Windows 10 before, this is your opportunity. And I see that I'm not interacting with it very well. Here we go, FME Desktop, FME Workbench. So I saw a couple hands, people who have not worked with FME Workbench or Desktop before. FME Desktop is the suite of these applications here, one of which is FME Workbench, where we create, author our workspaces. So while that loads in the background there, the publishing wizard allows us to connect to FME Server, and new, I believe, now I want to say this is 2016.1, or is it 2017 for the web connections here, Laura? Well, previously we had to manually enter in every time our FME Server URLs, and we'd only be able to save one of these connection details. But now we have the concept of web connections with FME Server, and I can show this here. Yes, new for FME 2017 are web connections for FME Server. Some of you have been using FME Workbench before. Web connections have been a thing for a while, but we have created now web connections of type FME Server. After we connect to FME Server, the wizard then has us define the repository name where we will be publishing our workspace. So in this example here, we have the training repository, and they're publishing the myworkspace.fmw. At this point, if you have any database connections or web connections, they can be uploaded with the workspace. And note here that for FME Server 2017, any OAuth web connection, the service needs to be added to FME Server so that you can configure it with your own client secret and ID, and then you will be able to authenticate it after publishing. So database connections are fairly straightforward, publish straight to, but now with OAuth web connections, we do require extra steps for security reasons. The last dialog in the FME Server Publish Wizard allows you to register which FME service you would like to run against. So in this example here, we're registering with the job submitter, which is the basic service. You also notice we have data download, streaming, KML network link, and notification service. Now you might be wondering, you did show me a bigger list earlier, didn't you, Ryland? Well, these are the public-facing web services that you interact with. All the other services like token, REST API, data upload, those are our utility services. So we don't need to interact with them public-facing. They're always working in the background. And one final note here, we have the ability to republish a workspace. So if you're working in FME Workbench, you publish a workspace up to FME Server, you make some more edits. If you're in the same session still, you can simply hit this republish button so that you don't have to go through all the dialogue again. If you've made some major changes to your parameters, or you want to register with a different FME Server service, then you will have to use the Publish Wizard again. So the first exercise we have here is publishing a workspace to FME Server. And I think that I will give you a moment to run through this exercise here. Actually, I'll run through this one with you because we did notice one important thing here is that our training license installed with these machines has expired. So we have I'll do a quick demonstration of how we can register our FME server. So we're going to start with exercise 1 here, daily database updates, how to publish a workspace. So if everyone opens up the web browser on their Amazon virtual machine, and let's go to HTTP localhost where we have our FME server installation. That'll bring us to the login window. The credentials are admin, admin, all lowercase, both matching the username. So now most of you will probably see this orange flag up here. This server's license has expired. So let's visit the engine management page by clicking this hyperlink. If that dialog has dismissed for you, you can find it here under admin, engines, and licensing. So new for FME Server 2016 is the way we handle licensing. All licensing is now served from the FME Server core. So we have multiple engines installed on different machines. They just need to point towards the core and do not need to be licensed separately. So we've removed a little bit of the overhead required for setting up the floating licenses if you've been working with FME Server 2015 or older. So if you click on this request license button, I believe this is the serial number that's expired. So we can simply remove that serial number and we'll request an evaluation license. So now we're going out to our license backend, fetching a new license from our license server. And there we go. We have a new license here that's valid for 7 days, expiring next week. Everyone should probably be receiving the same license as they're based on email. If you're working with FME Server and installation in your own organization, we provide free 7-day licenses. And if you sign up with a valid email, you have the option to extend that for either a 30 or 60-day evaluation. So you also see that with this license, we have 2 engines available to us, and we can see them both down here in this menu. So if anyone is having an issue having their local FME server installation on these Amazon EC2 instances, please send a message in that chat window and Laura will help you get sorted here. I'm going to continue on with the exercise here. All right. So this exercise is the first in a series where we'll be creating a workflow to do database updates. So if everyone could open up their FME workbench. This first dialog here lets you try out some simple data translations if you're new to FME Desktop. For now, I'm going to just hit this "Don't show me again" so that every time I start up my workbench, it will be hidden. So let's begin with an empty canvas. I'm going to click on New under Create Workspace. Just has a blank canvas here. And the first thing we're going to do is add a reader. So there's this handy button here on the toolbar, or you can go under Readers, Add Reader. I should mention that new for FME 2017, if you're familiar with transformers, we can actually just start typing in on the canvas, and we can see the list of all the readers below. So I'm going to choose the GML, Geography Markup Language Reader. So I double click on that. That brings me the Add Reader dialog. And I will open the file browser to navigate to our GML file, which is on our C drive in this FME Data 2017 folder. I'm actually going to click and hold to drag this over to quick access. So now I can just click here and that will bring me right to the structure of the folder here. So our data is in C FME Data 2017, Data, Emergency, and this fire halls. So that's C FME Data 2017 /data/emergency. So open up the firehalls.gml file. And for now, we're going to leave the parameters as their defaults, and we can just click OK to add that reader. And we're going to repeat this process to add one more reader for a KML data set. So again, I'm just going to type onto the canvas and select my Google KML reader. And select the ellipsis to browse to my data in the C FME Data 2017, Data, Boundaries, and this Vancouver Neighborhoods.kml file. Again, I'm going to leave my parameters as a default for now. And once this data set loads, I'll be prompted with all the different layers or feature types that are available. I'm going to just select the neighborhoods feature. So uncheck the select all box and just select neighborhoods and hit OK to add that in. All right, so we have our fire halls in GML and our neighborhoods in KML. They are likely in different coordinate systems. All KML files work in lat long. So let's add a reprojector transformer. I've clicked on the output port here of the reader, and with that highlighted, I can start typing in reprojector. Find that on here, and it's automatically linked now to that reader. So new for FME 2017 is this parameter editor here. You might be familiar with clicking on this cog to open up the parameters, but now we have this mode list dialog down here. So I'm going to change my destination coordinate system using this handy new panel. And I just have to hit apply. And then my changes are propagated. And now my transform is happy. All right, so at this point, let's add a reader to our workspace. And for now, we're just going to use the null writer until we need to actually start working with the data. For now, we're just going to have a simple workflow here to publish up to FME server. So I'm going to add a format null, which I recently learned existed. The null reader, or sorry, the null writer allows us to have a dummy writer here for us and this testing purpose here. So I'm going to leave my feature type definition as copy from reader. And this will prompt me to select which feature type I want. I'm going to actually select both of these. So I'm going to get two separate feature types that are attached to the same writer. So we have these fire halls and we have this list of neighborhoods. The purpose of this exercise here, or the workflow, is to divide up the fire halls by which neighborhood they're in. So to do that, we can add a clipper transformer. Connect the fire halls to the clipper, and the neighborhoods. Oh, that is right. Fire halls to the clippy and neighborhoods to the clipper. And you might notice there's cross lines here, and if that has bothered anyone for years and years, you can now right-click on the input ports here and get rid of those cross lines, so making our workspace a little bit more visually appealing. If we open up our parameters, if we view our parameters here in this parameter editor, just ensure that our clipper type is set to multiple clippers. We also want to make sure that we merge attributes so that the neighborhood name is copied from the neighborhood features onto the fire hall features. I'll hit apply. So we'll connect the inside to the fire halls, and we'll also have a copy of the reprojected neighborhoods by just dragging a line directly from the reprojector so that we have two output data sets here. So let's set a feature type name for fire halls. And you'll notice here that in this parameter editor, this mode list dialog, not only can we edit transformer properties, but also the reader and writer parameters. So under feature type name here, we can specify a dynamic name. So I'm going to use the text editor here, and I'm going to call this fire halls, and we can actually add in the neighborhood name itself. So I'm going to call it fire halls, and if I double click on this neighborhood name, then now for every feature written out, this will be automatically populated there. So apply that change, and you'll notice that the name here in the workspace changes as well. So best practice, let's save this workspace. I'm going to save it in my C Data 2017 workspaces. I'm going to create a new folder called training, and this is chapter 1, exercise 1. So best practice, let's make sure that this workspace actually runs in FME Desktop. So if it doesn't run in Desktop, I would run in Server. If I get a successful translation here, and I followed the instructions, we can ignore this feature here, this dialog here. This is because we had additional layers in that KML file that had features in them. We've chosen to ignore and only import the neighborhoods, so we can safely ignore this dialog here. And that's the also blue warning here at the bottom. Now let's publish up to FME Server. Right here, we're going to create our web connection for FME Server. We have to do this once at the start of the course, and then we'll be able to reuse this connection every time. So I click on the Add Web Connection, and I'll call this my FME Server. And the URL http://localhost, and our username and password is admin. So you click Authenticate to make sure credentials are valid, and they are. And now we can carry on. So in the publish to FME Server Wizard, we can see the available repositories, but let's actually create a new repository. This is something you could also do in the web UI. I'll call my new repository called training. If you want, you can enter a repository description that's viewable on the web UI. You can see this is blank, and workspace name is populated there as the saved name I have. We also want to upload our data so that we can have the fire halls and neighborhoods data sets up there. We don't have to worry about the user uploading them themselves. And select next. And here we'll just register with the job submitter, which is the default. And then we can hit publish, and it will transfer that file up to FME Server. All right, so how many people have published their first workspace up to FME Server? I'd like to give you a congratulations there. The hardest part is over. So in the interest of time for this course, the next few sections here, web interface basics, engines and licensing, running a workspace and jobs, I'm going to cover right now with you in the web UI itself. And then I'll just come back to the training manual here to make sure I've covered everything. So when we first log into FME Server, this is the main page. We can see handy buttons to quickly access the Run Workspace page, manage schedules, manage notifications. You can also see any recent jobs that you've run, any recent projects, which we'll get into at the end of the course, as well as our last published workspaces. And you can see this Chapter 1, Exercise 1 here. These are all handy options here, so we can simply click these links to go straight to the Run Workspace page. We also have the ability to favorite any workspace here. So if I favorite my Chapter 1, Exercise 1, it will always be available now in the side menu. On the left-hand side are all the capabilities of FME Server here, organized into 3 sections. We have kind of the general use authoring menu here, from Run Workspace, notifications, connections, and dashboards. We have this administration menu here. And we also have the help section here, where we can see documentation, links to the Knowledge Center, and also a link to our REST API. All of these menu options here are configurable in security. And we will not be looking at security in this course. It's not really an authoring role, but it is covered in the administration course. However, for the authors, one of the admin options that is very useful to check is this engines and licensing page. As you saw, we had to go here to request our license, but it also allows us to see if our FME server engines are available or if they're running any jobs. The ability to actually request the license is controlled by security. We are logged into FME Server as an administrator, so that's why we can see all the different options available to us. So let's run that workspace that we published up to FME Server. I'm going to select it by clicking on this last published workspaces here, and that brings me to the Run Workspace page with the Job Submitter service, the only one available, selected, as well as published parameters already populated. Now, one thing to note here is you might be asking, what is FME MF dir? This is actually a parameter that's published or populated at runtime when we click Run Workspace. This directory refers to the repository in which the FME workspace has been uploaded. So when I was going through that FME Server Publish wizard, I selected the Upload Data Files checkbox. So this Firehalls GML and Neighborhoods KML file were uploaded to that same training repository. And this parameter here will refer to the actual physical location on our hard disk where these files exist. Also available for every page, or sorry, everywhere you can configure a workspace are these advanced parameters where we can set job priority. So we can set, we can adjust the priority of our job in the queue, setting a higher number for less important jobs. If you want a job, give a job priority number 1 if it's the most important. We can also set job routing tags. So in the administrator's course, we review how to set up your FME engines to be dedicated to running certain workspaces. And this is where we can assign that here. We also have 2 parameters here, queue job expiry time, so we can ensure that our job doesn't wait too long before it's run. This is really handy if we're running a job on a schedule, as well as a running job expiry time. So we can set the maximum time a job can be run for. We can also override these parameters here by selecting the Run Until Canceled button. Also in the advanced menu here, we see a shareable URL. So you can share this URL with someone and they're brought to a separate page where they can log in and just run the workspace itself. And then a direct URL we provide if you want to incorporate this run workspace and its configured parameters with a web service. If we make any changes to the parameters, to the service up here, we simply have to click this refresh icon and the shareable URL and direct URL will be updated appropriately. You can also see a summary of the published parameters that we've set. So I'm not going to set any of these advanced parameters here, but I'm going to hit my run button. So now we see we're brought to a new page here where we can see if the job is running, and afterwards we'll be brought to the details page. If no engines were available, this would appear as queued, and we would see the status change as appropriate. So now our translation has successfully completed. We've written out our 14 features, which is great. That does match our translation here. Of course, I published so that information was erased. But the point is, ran perfectly just as it did on desktop. So now if I click this View Details button, I'm brought to the summary of this job that ran. We can view time is submitted, queued, started, finished, what time data was delivered. We can see all of the published parameters that our workspace was configured to run, as well as all of those advanced parameters like the engine routing tag and priority can be viewed here. And some additional information about the result data, including a status and status message. All this information can be accessed through the FME Server REST API or other transformers in FME Desktop. So we can also click View Log to see the same log here. It's very similar as what we'd expect to see if we ran the translation in FME Desktop. We'll see the same logging that we have configured in our FME Workbench options. Advantage here is we can also search for any errors or any warnings really easily. We can also download the job log directly from the FME server. As well, we can hit this button, Resubmit Job, to resubmit that translation, and we can see it's assigned a new ID. You don't have to wait for your job to complete to view these options. You can also click on the jobs page here, where you can see our list of completed jobs, any jobs we might have in the queue, or any jobs that are actively running. You'll see that the admin user also has permissions to cancel running and queued jobs, as well as to remove job history. Again, these are all items that can be configured by security settings. Also handy for FME Server 2017 is the dropdown to show jobs for specific users. This is really handy if you're in a larger organization where your FME server is configured, say, for Active Directory. You can view the jobs that are just run by you or other users based on your permissions. So exercise 2 just covers running the workspace in FME Server. It just goes over connecting to FME Server, logging in, examining the user interface as we did. So I'm going to skip over this exercise here, and if you'd like to review the content and some of the details, I would invite you to do so after the course has ended for the day. So in FME Server, we also have a new component for Server 2017, and that is sharing. So we wanted to introduce a sharing model similar to Dropbox or Google Drive. Before an FME server, you'd have to have an admin user come in and grant permissions to all the items, but if you've published an item and you are the owner, I think it makes sense that you're able to share that with other people. So I'm going to click on the repositories button here, and it brings me to my repositories page where I can see that training repository I created, and I can see that workspace within. So on the right-hand side here, you can see the share button, and I would be able to select another user or another role. A role would be a group of users on FME server that I can share this repository with. So you can select and also choose permission, and we've tried to summarize these so you have run access, download access, or full access to that repository. And you'll see this share option on many of the pages, including schedules, resources, connections, projects. It should be spread throughout FME Server, the web UI. So I'm going to go back to the home page of FME Server, but just by clicking this icon on the top left. So we've covered run workspace, showed you how to run a workspace and view the job details. But another major functionality of FME Server, one of its core capabilities here, is this schedule. So if I click on Manage Schedules, we can see FME Server does come with a couple schedules by default. And I'm going to enable one of these right now, this dashboard statistics gathering. I think it'll be really interesting if we enable this dashboard right now, and then later on in the week, we can see the activity on FME Server through this dashboards here. So you can follow along if you like to enable your dashboards as well. So if you click on the dashboards here, we're brought to this dashboard, or sorry, the schedule configure page. I'm going to select the box to enable it, also to run immediately. And I'm going to have this repeat I'm going to set it to every 4 hours. So you see we have a variety of different options we can set here. If you wanted it to expire, you could set an end time here by using this calendar option, but I'm going to just have it never expire. I'm going to leave the workspace repository and job statistics gathering as is, and I'll just make sure to enter in my admin credentials here, and then select OK. And now running on that schedule will be that dashboard statistics gathering. So the next exercise here is about creating a schedule. and also testing out this sharing. So that is here, exercise 3, sharing and scheduling. And the purpose of this exercise is to test out the sharing permissions and also to create a schedule. So I'm going to open up a private window for Google Chrome so I can log in as a separate user. You can also log out of your current session here just by selecting top right corner admin log out. But whenever I'm working with FME Server, especially in permissions, I like to have 2 windows running, one of these incognito or private windows so that the cookies and session history are kept differently. So in this separate window here, if I go to my FME Server instance, you'll notice that it thinks I'm not logged in. That's great because it, again, is keeping its cookie cache and browsing session separate from my main window. So one of the other default accounts that's created with FME Server is the FME Server user. That's one of the roles that we spoke of earlier. So I'm going to sign in with credentials user. And you'll see here on the main page, we have very limited options here. We only have the option to run a workspace and see jobs, whereas as an admin user, you can see a whole suite of other options available to us. If I click Run Workspace here, you'll notice that I only have access to the samples repository. So for this exercise 3, we're going to share the training repository with this user. So if I come back over here to my admin user, and I'll click on repositories and click the share button for training, I can type in that user account there, select it, and I'm going to select the permission that they can run the workspace. This will, by selecting can run, this prevents them from downloading and making edits to our workspace. So I'll click OK to set that. Now if I come back to my Run Workspace page, should just have to give this a refresh. In the background, all of these repository, workspace, and service items are populated by calls to the FME Server REST API. So we can see that I shared the repository, and instantly that is set in via the REST API calls in the background. Now I can select that repository. So because I selected that repository, I only have one workspace in there. It's automatically selected, and you can see my defaults and my service. And I will hit run here to run that workspace. So if I come back to my admin user and I navigate to my jobs page, I can now see that the the username column here, we have that user there. And again, just to highlight, I can just show jobs for just that user. So you can kind of keep a tab on what your colleagues are running if you wish. So the second part of exercise 3 is to create a schedule. So we click on the schedules page. Make sure you're logged in as the admin user for this. You can click on new. And let's create a test schedule to verify that our FME Server scheduler is working. So we have to define a category here. We have 2 available, but I can also start typing to create a new one. I'm going to create a new training category. And I will also have this workspace run immediately. And let's have this run every 30 seconds so that we can kind of verify that the schedule is running. I'm going to navigate to my training repository and that exercise 1. I'm going to leave my published parameters as they are and also my advanced parameters. You'll notice here in the schedule page, we also have the option to set notifications. So notifications, we can have an event run in response to either a successful or a failed run of this workspace, and notifications are definitely something we'll be diving into later this week. So hit OK, and I can see now that every 30 seconds this workspace should run. If I go over to my jobs page, under completed, I see that we have it kicked off here at 10 o'clock and 58 seconds. So if I refresh this page every 30 seconds, I can do so by navigating to one of the other pages, the queued tab, for instance, and coming back. I will see that every 30 seconds we have a new job run here. So I've left my completed jobs here window up, and let's do a refresh. And all things hopeful, we should have a whole bunch of workspaces run on schedule. And we do. See every 30 seconds honoring that schedule, which is great. I'm going to just leave that running because why not? So moving on with the second half of this morning, or afternoon for some of you. We have a section here on source data management. So FME workspaces start, of course, by reading data from a source data set. We can connect to not only all of your favorite file-based formats, but also we have the ability to connect to a variety of different web services and databases as indicated here by this dialog. So to connect to these database and web services, we have the concept of these named connections. So first, we'll speak of the database connection. So what is a database connection? It's essentially a container of your database connection parameters. So it can include the server, port number, username, password, or token. The parameters will vary, of course, depending on the database format. The advantage of using a database connection is you do not have to embed your authentication details into the workspace. Of course, that is a security concern if you're working with production-based data sets. And you can reuse these parameters, these database connections, with multiple workspaces. So you can have two workspaces that reference the same database connection, and if you need to change anything to do with the credentials or the connection details, you only have to change that connection in one location, and then each workspace will be able to access those changed details. So in the FME desktop training courses, we do likely cover database connections. We're not going to get too involved with them in this course, of course. But just noting here that once you create a database connection in FME Desktop, we can upload that to FME Server so that any workspace in FME Server can reference that connection. If you update your database connection parameters, you will have to change it on FME Server as well. So FME Desktop and FME Server both manage connections separately. They both have their own secure repository. In the case of FME Desktop, we have an encrypted file on your desktop, and for FME Server, we actually encrypt that in the FME Server database. So that's your Oracle, your SQL Server, or Postgres database that sits behind FME Server. And for web services, we can think of the web connection in the exact same way as a database connection. Don't have to embed any credentials, including tokens, into a workspace, and you can reuse it among multiple workspaces. The one difference here is that for publishing web connections to FME Server, we actually have to add that service to FME Server, authenticating it for your own application, and then also separately authenticating that in FME Server. As it's a different host, a different client, the credentials need to be re-authenticated for each machine. That's similar. You may experience that if you log into Google from a different machine and you have two-factor authentication, you're going to have to enter your two-factor authentication ID. It's just based on your IP address. So as I had mentioned earlier, we can store our source data sets in the repository of FME Server. When we published that first workspace from exercise 1 to FME Server, we selected that upload data files, and it by default published them to the same repository that the workspace existed. Now in this upload data files, you can, if we had selected the select files, we're presented with a dialog where we could actually select certain files. So we wouldn't have to upload everything if we didn't want to. We also have the option to select a different location. So we'll do an exercise on that right now. Well, I guess before that, I should mention that we can upload files at runtime. So I'll demonstrate that here actually in the web UI. So if I go to my Run Workspace page here, I can see that my source files are pre-populated. As I mentioned, this FME mfdir is a parameter that will be populated at runtime that will specify the repository where the workspace exists. However, if someone interacting with the web UI wanted to upload their own data set, they would be able to navigate to temporary uploads and upload files here, and then subsequently select them to be used as a source data set. As well, you can navigate to any other resource folder on FME Server. And we'll be working with these resources in later exercises in this course. So just a few cautions here about uploading data sets. If we're using the FME Server publishing wizard to upload our data set, as we did, and we left everything as default, that's uploaded to that workspace repository, that means that that data is only available with that workspace. So it's not a very efficient method if you're going to be reusing this data for other workspaces. You might want to leverage the resource folders in FME Server instead. As well, if we upload to the temporary folder, the warning here, these files may be deleted after a period specified by the FME Server admin. There's actually system cleanup tasks. You can see here under the admin menu that we can set or specify how long temporary files are present for. And then if we upload into, this is the resources of FME Server, if we upload into, say, this data folder, This is where data will be available for other workspaces, and it's persistent. So that runs us into exercise 4, publishing data to FME Server. So we've already created a simple workspace. We run it in FME Server. Now maybe we want to have the ability to have the user upload data with it. So I'm just going to start off with the completed workspace here, rather than go through the steps to create this one. So in this table here, we have the location of the end workspace. So I'm going to go to FME Workbench and File, Open. I'll navigate to my FME Data 2017, Workspaces, Server Authoring, and I'm going to open up Basics, Exercise 4 Complete. So you see, very similar to the previous workspace, except this time we're working with voting places instead. So since we open up this completed workspace, we can scroll all the way down to step 7, publishing it to FME Server. So I'm going to again select that Publish to FME Server button in the toolbar. All the buttons here in the toolbar are configurable, of course. So if you don't have them, you might have to go under the File, Publish wizard. And it looks like my FME desktop is tired there. So I'm just going to quickly reopen that. In my recent workspaces here, I can see that last workspace I had open. And there we go. Publishing it up to FME Server, I can select that existing web connection. And selecting Next, we'll again publish to this training repository. And this time, instead of selecting this Upload Data Files checkbox, let's navigate to the Select Files dialog. So since we're working on an FME server that's installed locally, our FME server core and engines do have access to all of these files. So in this instance, we actually wouldn't have to upload the data. If the core and engines can reference the data, whether it be locally or via a network path, a UNC path, then we don't have to upload a separate copy of the data to FME Server. So I'm going to select all the files here. Actually, I'm going to go a little bit off-road here. I'm going to select just my neighborhoods KML and leave the GML unselected here. So I'm only uploading one file. I'm leaving it as a default location, so that one file will only be available in that training repository. And it has this warning here that I haven't uploaded the data. FME Desktop recognizes that, and it is letting me know, hey, your workspace might not run if FME Server doesn't have access to this file. So I'm going to hit all right, that's fine. And then I'll again just leave it with the job submitter. Publish that workspace. If you publish a workspace through FME Workbench, you can actually click on this handy direct link to open up the page in the web browser. And what is our default browser? Looks like on Windows that is not selected. So I will copy this and paste it into my browser. So see here now we have that default directory, that parameter for the source KML file, and we have this default location when I was creating my workspace. As I am working on a local machine for desktop and server, this file is accessible. However, we do have the option to upload that file as so. So I'm going to navigate, I clicked on the ellipsis to open up the file selection box. I'm going to choose temporary uploads. And if I navigate to my data 2017, data elections, I actually have to upload both the election voting and this XML schema file. Similar to how a shape file has multiple files associated with it, so does this GML. So I select both those files, hit upload, and you'll notice that both of them are automatically selected. Now this is important to note that if I left this as is, FME Server would treat each of these files as individual source data sets, and that's not how the GML is structured here. So I'm going to deselect this supporting XSD file, and now my GML reader will just read this one file, and it knows to grab that support XSD. So hit OK. And now we can see, as noted here, that file's been uploaded, and it just has a simple reference there. So when I run my workspace there, it should be running as it does in FME Desktop. Just showing you a different way in which we can have the source data available to us. All right, so I've talked of this resources in FME Server, but I haven't actually showed you or explained in detail what it is. So resources is kind of this inbuilt file management system of FME Server. So in the web UI here, it's accessible on the left-hand menu. And here we see a list of all of our resource folders. We can see our logs in the resources. We can see temporary files. And we also have access to a shared repository for FME Server engines if we wish to upload any custom coordinate systems or custom transformers or plugins. They'll be shared across the FME Server installation. And if we want to upload data for other workspaces to use, not just one workspace, we can create folders in this data resource folder. And this actually, all these resource folders are a mimic of the file system in our FME Server system share. So this is probably more important to just admin users, but by default, this resource folder is created in C program data. This is something that's configurable when you install FME Server. It's a hidden folder by default. It's where all supporting files go for many different softwares. So you see here in Safe Software FME Server. This is actually my resource folder, and you can see that the file structure here matches what I see in the web UI. You'll notice here that already my temporary items have been cleaned out that I had recently uploaded. So for other exercises in this training course, we'll be making use of the resource folder. We can upload directly via the web UI. So we have, once we're in a writable folder here, we can create new folders and upload files. You can also do the same via the publish wizard by selecting a different location in the FME Server publish wizard. And alternatively, you can also upload files directly into this FME Server system share folder. Although likely this folder is hidden from most users, the recommendation would be to either utilize the web UI or the publish wizard. All right. So FME parameters for FME server. For the FME desktop users out there, you may have noticed that under the user parameters are a whole list of FME server parameters that are all locked. You can't edit these, at least the titles, that is, or remove them. So all these parameters here are always populated when we run a workspace in FME server. So we can leverage these in our workspace, referencing them in transformers, readers, and writers. And we'll see some examples and exercises where we utilize some of these FME server parameters. We can, yeah, as I mentioned, these are already, automatically populated at runtime. So exercise 5 has us working with the resources in FME server. I'll work along with you on this exercise as well. If you haven't completed exercise 4 and published it to FME server, it's not a prerequisite. My mistake here, that comes in a later exercise. So let's create a folder in the FME server web UI so that we can upload some data with the intention that this data can be reused for other workspaces down the line. So if we log into our FME server web user interface, we can select resources on the left-hand side menu, navigate into the data folder, which is the best practice place for us to store all this reusable data. And let's create a new folder called election. Again, here just to emphasize the relation here between the file system and the web UI, we now see that election folder has been created. So let's click on the election folder to navigate into it. And we're going to create a couple folders in here called input and output. We'll browse to the input folder where we're going to store that source data set. And we're going to upload the source data sets for the translation we'll be running in this exercise. And the file paths are all listed here. So I guess what I'm going to do here is I'll have that page open on one side. I'll be working with my FME server here. So I'm going to upload 3 data sets here. I can do this really easily by drag and drop onto the web UI or using that upload option there. So in my FME data 2017, go in data, elections, and we'll upload both that GML and XSD. So drag and drop. And also in data boundaries, that Vancouver neighborhoods came up. So in FME Workbench, I'm going to start with a workspace using the open menu here. I'm going to open up basics exercise 5 begin. So that's in the C data 2017 workspaces server authoring exercise 5 begin. So up until now, all of the workspaces have had this null writer. Now that we know about resources, we can let's add in a proper writer and point it to that output folder so we can actually start to get some data. So let's add a writer. I'm going to click on, actually I'm going to type in the canvas here. It's something I'm still getting used to. It's such a handy shortcut. So select my geodatabase, file geodatabase API writer. And for my data set, I'm going to specify the output to be in the C FME data 2017 output training, and let's create a new folder, department data. I guess what I should have done is type that in here, department data. There we go. .gdb. All right. So feature class or table definition, we're actually going to choose, excuse me, we're going to choose none here. And then I'll hit OK. The reason why we don't need to worry about specifying any feature types is because we can reassign them from the null writer. So to move feature types, let's first do this for the neighborhoods. You'll see here that it's having my parameter editor here on the side, or you can open up via the cogwheel. Same options are available. We can actually transfer which writer this feature type is a member of. So I'm just going to select that drop down and hit file GDB. And now you'll notice that the parameters for the file geo database come up, and we have to populate notably the geometry. So I'll set that as geodb polygon and hit apply. And I realized, so sorry, voting places, those are points. geodb point, and it's the neighborhoods once I switch over the writer that I have the polygon geometry. So we can do that for both of the writers, the feature types that we had set up for null, and that just is a little bit faster, or a little bit more convenient, I should say, than deleting the null writer and completely re-adding and redefining those feature types. So again, neighborhoods, select the writer as and set the geometry polygon, and voting places, select the department data and the geometry as point. One very quick thing we're going to do here, since we're just working in this training environment here, I'm going to set the parameter on the overwrite existing geodatabase to yes. So in the navigator window here, if you expand the file geodatabase writer and the parameters, you can double click here and set that to yes, so that I'm not just adding rows and rows and rows. I'm just going to have the fresh data set regenerated each time. So I'm going to save this workspace and use save as and throw that into my training folder. You can overwrite if you wish, or save it to any other location. And I'll just run this to make sure that it is successful in desktop. And again, we just have that warning because we have unused feature types within the source files. Key thing to note here, successful translation. So I'll publish this to FME Server now, again using that same FME Server web connection into that training folder. I'm not going to upload the data files here because this will just have an example of showing you that when the data is local to FME Server, we actually don't need to, of course, create another copy. And then I just will have that registered with the job submitter service. hopefully we can safely ignore that. Desktop is tired again. But if I come into my FME server web UI, see if that did publish. So luckily we got that in there. So we'll see that my published parameters here are all the defaults. So for my source data sets, I'm going to leave as is. But what I'm going to do here is specify to have my file geodatabase written to that output folder I created. So if I navigate to, I click on the ellipsis there to select a different file. I open the data folder, election, and output. And again, you'll see that we have a different parameter here. Before we were working with FME MF-dir, which was the repository folder where the workspace exists. Now it has this shared resource data. So that is the absolute file path on our file system that points to that resources folder. So when this workspace runs, it's actually going to be referencing that C program data, safe software, FME server, that whole string will automatically be populated. So I'm going to run the workspace here. In the exercise, in the last couple steps here, it actually explains how we can set these parameters as the default using FME Workbench to do that. So that's in steps 8, 9, 10. That's something I'm just going to skip for the purposes of this exercise here. But it's just highlighting how we can actually set these defaults with FME Workbench. And then when we publish that workspace to FME Server, those defaults will already be set in the web UI so that we wouldn't have to go out like I just did to the to select that resources folder. And let's just verify that. So translation completed, but let's verify that there actually is some data written. So if I come into elections output, I have my output GDB. I didn't specify a name for the geodatabase, so it just thought output was my name there. If I came back in here, yeah, so I didn't specify a database name. That's why I just threw it in as output. So that's a quick tour of the various ways we can interact with the resources in FME Server, how you can set them by navigating in the FME Server web UI, or you can also take these parameters and use them directly in FME Workbench. Now, I wouldn't expect any of you to have been able to guess that file path with the parameter there. So if you came into here and right-clicked on, sorry, if you selected any file here and you click on properties, you can actually see the system path reference to that file. You would be able to use this as an easy way to obtain that path to copy and paste into any workbench. So this section here, running the job submitter using a URL. This just backs out and highlights again that when we're on this run workspace page, under the advanced option here, we can set, there we go. We can set, not set, we can grab the direct URL and we'd be able to run that workspace directly. So I can just, I'll demonstrate that by just copying this link. And so if I paste it in a new window, we see that now I'm required to enter in the username and password. This is a different service. We're directly accessing the FME job submitter service here, as we can see in the link. So I can type in my credentials here. And then when this workspace runs, depending on what we've set up in the parameters for synchronous or asynchronous run, you'll notice that we just have a very simple response page here that just tells us that our job has succeeded. We can't view the log or anything. Again, this is something that you can use with any web service. If I had changed the service mode here at the end, so that's synchronous, if I change that parameter at the very end of this URL string to have it run asynchronously, just going to copy this to highlight that. So I'm going to open a new tab here. I'm immediately brought to the job submitter window here. Asynchronous will just check if the job submitted correctly, whereas synchronous waits for the job to complete before rendering a response in this window. So last topic we'll cover here this morning in the introduction to FME Server is speaking of job chains. So job chains are workspaces that run in sequence one after another. And there's a few ways that we can go about creating a job chain. So one way to do so is to actually replace our traditional writers with this feature writer transformer. So using the feature writer transformer allows us to write out data mid-translation and then continue on our workflow with additional logic. So in this example here, we have some zones coming through a validation tool, and then any that fail validation, we're looking for, we're using a string searcher to replace invalid values. We use the feature writer transformer in place of a traditional writer. And so this allows us to write the data set out and then continue the translation here. And here it sends out a tweet letting us know that our data is ready. So by using a feature writer transformer, you can have additional operations act on the data after it's written, such as attaching it to emails, sending out these tweets, or running other validation workflows, for example. Another way we can implement a chain is to use the FME Server Job Submitter transformer. So this transformer triggers a workspace to run on FME Server. When we configure this FME Server Job Submitter transformer in FME Workbench, we can configure all the parameters as we would in the FME Server web UI. And we can use this transformer in a workspace. So that means we can actually invoke jobs on FME Server without actually interacting with the web UI. We can be on any other machine and have jobs run as part of our workflow. So our job chaining can be entirely on FME Desktop, but we're actually calling processing tasks on FME Server. We can also use a parent-child approach, which uses a parent workspace or a master workspace to run a series of child workspaces in sequence. So this one master workspace here simply has a bunch of FME Server Job Submitter transformers. So we're running one workspace in FME Server. If that's successful, run the next one and the next one and so on, getting to the end goal of sending out this tweet message. The advantage to setting up a parent-child workflow like this is that if any error is encountered along the way, we can insert logic to handle that error. In this case, it's just logging it out to a text file writer. We can also author job chains to use this conditional processing approach by having a tester transformer to maybe check on various parameters in our FME Workbench. And then based on the value, we can have different FME Server jobs run or different or the same job with different parameters configured in each. And FME server job submitters, again, use the same connection, the web connection, as FME server publishing wizard does. So this last workspace here, we will create a simple job chain here to run on FME server. So I'll open up FME Workbench, and I will create this workspace with you all here as well. So the first step here is let's generate a workspace with these parameters here. I'm going to use the generate button here. So reader format is GML. Our existing data set is going to be the FME data 2017 and the data folder, elections, that voting GML file. And our writer format is going to be spatial light. And we can leave the writer data set empty for now. I'll select OK. It'll start creating that workspace. When prompted, we're going to leave both these layers selected. And we can see now we have two feature types coming in from the reader and two feature types on the writer. So for this exercise, we're going to leverage the resources folder on FME server. So we're going to grab the string for the parameter of the Vancouver neighborhoods. And if you haven't done so already, just make sure that in order to do this exercise, we need to have that election folder and the input with the GML and neighborhoods files. So we'll edit the workspace to reference these files directly. Two ways to do that. One is we select the file, the checkbox here, click on properties, and we can get the system path. So I'm going to copy that for my GML file, and I'm going to use that as the source. So I just went to the navigator window, double clicked on my source, and I'm just going to paste that new value in. Oh, I think I just copied it, didn't I? The values are also in the training manual for you to copy and paste. So we'll do that for the reader. And then also I'm going to copy out the parameter for the spatial light writer. So I use my navigator window here. Go to my spatial light and then paste that dynamic data set in there. And one other thing I'm going to do here is, as I did with my file geodatabase, I'm going to put overwrite to yes, because we're going to do probably a few runs of this workspace here to make sure everything's working. So let's save this. I believe this is exercise 6. I'm going to, if I ran this right now, would it run? Of course, it would try, but because we don't have these parameters being populated in FME Workbench, this translation would fail. So in order to test this workspace, I actually have to publish it up to FME server. So now that it's published, go to my home page where I can see my recently published workspaces. And I'm going to simply hit the run button here. So read in that data set that I've already uploaded in that previous exercise, and it's going to write out to that resources folder. So one important thing is we actually need to grab that output file. So if I go to my resources, data, election output, I have that voting divisions. I'm going to select that file and actually download a local copy. So that will save it in my user admin folder there. So if I go, there it is here. We'll need to reference this file in an upcoming exercise, so I'm just going to leave that window open for me. As the training manual suggests, we can also push that file into our data 2017 folder, just so that everything's in one spot. So that's our first workspace here. Now we need to make another workspace here because, of course, we're doing some job chaining. So I'm going to come back into Workbench, go back to the Start page, and again, generate a new workspace. So this time the source data set is file GeoDB API as your geodatabase. I'll navigate to my data 2017 folder and into the data and addresses, selecting that geodatabase. And the writer is the geodatabase as well. And we'll throw that into the output folder, training, and we'll call this one new addresses. So we'll add a spatial light reader. So this is why I had to grab that data set. So I can actually, when I set up a reader, I always have to reference that file. So I'm just going to drag that onto the file name here, or the window. There we go. Well, actually, that's going to be bad if I throw it in the output folder. I want this file referenced. Oh, it moved it. Well, that is a good case for not, or a good case to follow the directions. I'm going to just move this back to my downloads. I don't want that file moved there. There we go. So if I just drag and drop onto that data set, I have it set up correctly now. So on this select feature types, I only want the voting divisions. And just looking at the time here. So this is workspace B that we're completing. In the interest of time, I'm actually going to open up the completed workspace B. That also saves me from all the errors I may have made. So basics, complete B. One thing I believe for this workspace to run is I need probably my spatial light database in the right spot. I think we're going to be okay though. We're all referencing resource locations here. I'm going to publish this complete B. So we have an A workspace, this chapter 1 exercise 6, and now we'll have this B workspace. And the idea here for my job chaining is now that I have 2 workspaces up there, I can run a job chain by using the FME server job submitter transformers, effectively creating a master workspace. So I'm going to have 2 workspaces here run in parallel. So I'm going to add 2 FME server job submitters and connect them up. Of course, to start this translation, I need some type of feature. So I can add a creator, and this will create a null feature just to start that workspace. In the first server job submitter, I'm going to select my connection, And that training workspace, that was the first one there. I'll have wait for job to complete set to yes, because for the second workspace, it's going to reference my Spatialite database. So if that workspace is successful, complete successfully, let's start workspace number 2. And that would be that workspace B. And again, I'll set this wait for job complete to yes. I'm going to omit quite a few of the steps here in the training exercise, and we'll simply just run this as is. So I have FME Workbench creating a dummy feature running 2 workspaces in FME Server, and we have a nice failed message here. So there's definitely something wrong with one of my parameters there, but I'm just going to show you that we can have 2 run in succession. I set wait for job complete to no, so that just pushes the feature through regardless of a successful or failed translation. So we have FME Workbench calling FME Server twice. So that if I come here in my jobs completed page, we can see I had my exercise 6 run, which did fail, but it still kicked off immediately the second exercise there, which failed, but just showing that simple kind of chaining concept. So if you'd like to run through this workspace here, I invite you to do so as we've run out of time for this first session here. Just like to note, at the end of each chapter, we also have some simple troubleshooting tips if you're having trouble connecting to FME Server from FME Workbench, or some simple troubleshooting tips if workspaces are failing, where you can look for answers. So in this first section here, thank you for staying with me for these extra couple minutes. We've learned FME Server has 3 core capabilities: self-serve, real-time, and automation. FME Server is the same processing core as desktop, but we do require FME Workbench to publish. We went over the basic roles in FME Server: the admin, the author, the user. We spoke of the FME Engines core and introduced the Job Submitter web service. We talked a little bit about the FME Server infrastructure. We went over the FME Server interface, the web UI. We examined some of the common pages that users access. And then speaking a little bit on the name connections for database and web, and also looking at workspace chaining. Just that simple concept. If you want to actually get your workspace chain to run successfully, please run through that 6th exercise there. Did a whirlwind through the introduction to FME Server. We learned about its core capabilities, a little bit about the architecture, investigated some of the common pages in the web UI, including running a workspace, viewing job logs, setting up a schedule, and then at the end of yesterday, we very briefly touched on job chaining. So that all, everything we covered yesterday is fairly simple material as far as FME Server goes. Now we're going to get more into some of the other aspects, some of the more complicated aspects, and that is why you may have noticed we have actually split up the self-serve with FME Server into 2 parts. Now, this being the first time we're delivering the 5-day course, we'll see how far we get through part 1. We may or may not end early or continue on into part 2. But either way, we'll be running for 2 hours here until 11 a.m. Pacific time. And roughly an hour into the session, we'll have our break. So I'll just start off by showing you in the web UI here. Now you may have recalled that I started my dashboard schedule yesterday. And if any of you had also done that, you can either watch or follow along in your own installation. So my dashboard jobs should have been running every 4 hours. And if I go here to the dashboards page, I can see that about 6 o'clock this morning, all these were updated. So now I can see, I can start to see the daily total number of jobs run on FME Server. Oh, look at that. 1,714 jobs ran yesterday. That must be our 30-second schedule running. And you can see today we've only had a measly 715. These dashboards do ship with FME Server. They are available for you to download, fully open, not password protected. You can edit them as you see fit, or you can borrow pieces from them, duplicate them, and create your own custom dashboards. So these are the 5 that we ship with FME Server. One of the handy ones here is the daily average queue time. This is a very handy dashboard if you might need to generate some proof. Hey, I need another FME engine on my server. I'm always waiting for my jobs to complete. In our case, we've had 0 seconds of queued time, which is great. Okay, so self-serve with FME Server. This revolves around the idea of taking away the user requests from you, this expert FME Server author, and you kind of give them the power to do their own data transformation requests. You do the initial setup, and then after that, they're kind of on their own. You don't need to answer emails and fire back data sets to them. So we talk of 2 self-serve systems with FME Server. We have the data upload system, where we provide a service where a user can upload their own data set to be processed in an FME Server workspace. And the data download system, where a user is able to serve or request data themselves. So we mentioned that data upload can be used from any FME Server client, and that includes not only the web user interface, but any other custom FME workspace, custom web page, or application. As I mentioned yesterday, the FME REST API has all the calls that the web UI uses, and you can incorporate and customize your own custom app or page. So the data upload example that we list here, a property developer submits a planning application containing a DWG dataset. FME Server can automatically recognize, maybe through watching a particular folder, or if it's sent directly to FME Server via email, then FME can launch a particular job or job chain to process that data. And then for data downloads, you might imagine where we have a page actually much similar to this pictured here, where we can actually draw and create a clipped or a polygon and have that area clipped and give us the data set. This is an excellent opportunity to show you we have a number of examples of FME Server workflows that are available at demos.fmeserver.com. So if you want to see some of the front-facing applications, these are some very simple demos that we've set up. They're all running on an FME cloud instance. You can interact with the demos. You can also download the workspaces and any custom JavaScript that was used to create the page. So I can go here for data distribution raster. This is, I believe, the same one that's shown in the training manual. So here it's a simple Google map that's set up. We can zoom in, click on an area, draw a polygon of interest, and then we can select a different format. These are all published parameters in an FME workspace that's been published up to FME Server. After you set your parameters, you can hit this request data button, And you can see it's running on this FME Cloud instance here. You can see all the parameters that we submit to this raster download workspace. So this is just a simple HTTP call. And then our data is presented here, zipped up, ready to download for us. So this is just one example of the self-serving application of FME Server, the data download particularly. And back on this demos.fmeserver.com or playground.fmeserver.com/demos, you can look at a variety of other demos that we've created here for you. And again, all these have an associated Knowledge Center article here where you might be able to learn a little bit more about how the workspace works, and then links to the data itself and the fork on GitHub if you wish to interact with it that way. Right, so FME Server implements self-serve through a variety of services, such as the data upload and data download. And in simplest terms here, a service is this piece of software that is handling the communication between the client, such as the web interface or that custom web page, and the server. In this case, of course, we have FME Server as the server. So this table lists the various transformation, utility, and notification service that FME Server has. You may recognize that these services here are what we can register our FME workspaces with. And then these utility services just work in the background here. The notification services we will interact with more in the real time with FME Server. Yeah, so this just, again, just reiterates registering with those services of FME Server. And then this last image here highlights how, although we're registering with a transformation service, each of these services is still intimately linked with the notification service, as we can directly set a topic to notify upon success or failure of a translation, a job, and then we can set up some logic with FME Server notifications to perhaps clean up after a failure or continue a chain of workspaces. So creating data download service is very easy. It is as simple as just selecting the data download service when you publish to FME Server. What happens? The reader processes your data, you have all your transformers, and then you have your traditional writers sitting at the end of your workflow. In a job submitter service, the typical workflow runs much as it would in FME Desktop. However, when you do the data download, rather than writing out that data to the output dataset location you've specified, instead we write the data to a temporary location and compress into a zip file that data and present a link to the end user for download. A quick note about the data download files is they are also temporary themselves, and you can configure a cleanup on those items. So if you're interacting with a data download service in the web UI, you are presented with this data download URL. As we saw when I was using the demo, I actually had the link presented to me on that same page. And that's because when you make a REST call to the service, one of the responses is either an XML or JSON, is a parameter containing the URL as a value. So a data upload, it is, as I had mentioned, part of the self-serve feature of FME Server. However, itself is not a transformation service, rather it's a utility service. So you can't actually register a workspace specifically to the data upload. However, we leverage the data upload depending on our workflow that we've created. So yesterday when we were using the uploading our files in the FME Server Publish Wizard, that was utilizing the data upload service in the background. So if we were interacting with the FME Server REST API, we can use post calls that would invoke the data upload service to grab the data and process it into FME Server. Okay, so let's create our first data download workflow. So the idea here, we have a theme for this set of exercises. We're a technical analyst working in a GIS department, and it's our job to provide people with orthophoto imagery. And normally what would happen is people come to us and say, hey, give me this area, give it to me in this format, and then we would have to go and process that and then provide them with the output. What we're doing here is we're going to leverage FME Workbench to author a workspace where we can now give the power to that user requesting it. We can go do more important things with our time. So we'll start off in FME Workbench. And you can start with a blank canvas. And the first thing we'll do is add a GeoTIFF writer. So again, I'm just quick typing on the canvas. Now in FME 2017, we have readers and writers listed. So I'll hit enter there. And our source file is in our favorite data folder, C FME Data 2017, Data, and let's navigate to orthophotos, and we can select any orthophoto here. I'm going to follow along with the exercise and select 06-07-LM. Now, one thing we want to do here is actually jump into the reader parameters, and we want to make sure that the feature type name is actually from the file name. So the default for this reader is to set it by the format name. So if I left it as default, my reader would likely be called GeoTIFF, but now calling it from file name, I'll have that 0607. Hit OK there. And another thing we're going to do here is set the workflow options to single merged feature type. Now this is going to help us out in subsequent exercises here. Having the single merged feature type allows us to read in a whole bunch of data files, and we will not have to add them as individual feature types. They can all pass through this one reader. So you'll notice here that the reader is noted with the all, and that just reflects that single merged feature type selection that we did. And in the navigator pane here, you'll see the name of the GeoTIFF file that I had selected. So our goal was to write out these JPEG images. That's what we've had to do manually, but now we're going to automate this. So let's add that JPEG writer. You can see I'm really caught in the past here. I'm always going to be clicking my toolbar icons rather than typing in. For the output, let's specify our CFME Data 2017 And let's just throw that into the output folder. Feature types, we're going to define it from the reader itself. That will save us a little bit of time. And now your workspace should look similar to how I have it here. All right, so now we need to add in a little bit of logic here. We want to not just convert from GeoTIFF to JPEG, but let's give our end user a little bit of customizability in terms of resolution. So we can add in the raster resampler transformer, connect that to our reader, and we're also going to use the raster mosaicer. And we'll connect that in sequence here. Now, raster resampler requires us to set some parameters. So let's select that here, and I can go just in my parameter editor window. This again is a dockable window here, so if you wanted to move this around and work with it elsewhere, you have the option to do so. So we'll just set default spacing here of 5 by 5. And sorry, we should have cell size specification, not to the rows and columns. So your parameters for the raster resampler should look like that. And let's save our workspace here and test it out. So I'm just going to throw this into my FME Data 2017 workspaces, this training folder I created yesterday where I've been saving my stuff. So this we'll call chapter 2, exercise 1. Let's give this a run. Translation was successful. Let's make sure that data was actually written. So I can click on the reader here, and we either have a quick button here to inspect the data. It will open up FME Data Inspector, view that data, or I can also select this to open the containing folder here. And I can see that JPEG image has been written with an associated world file. Now we can publish this up to FME Server to make sure that it will also work up there. I'm not going to upload my data file here because I know I've specified a local path to FME Server. So I don't want to create any duplicate data at this time, so I'm just going to hit next here. I register it with the data download service. And I'll just note out here in the properties, if you select the edit button, we can actually select which writers will include their data in the data download zip file. So by default, I only have one writer in my workspace, so that's automatically included this output JPEG writer. So I publish that. I'm going to copy this link. So I have a quick access to FME Server. I'll see that data download is automatically selected, mostly just because it is the alphabetical order we have here. Once you run a workspace in FME Server, for each user, it will remember using cookies your last configured parameters for the workspace. So if I run this, we should get a data download link. And let's just verify that we have the correct data in here. So I have my output folder, and then there's that JPEG image and world file. So that was a very simple data download. You just made a data download service. How useful is it? Well, we can convert one particular image to one JPEG, and we're automatically specifying some parameters. We're going to enhance this workspace so that we call it dynamic, so it can work with multiple files, and also will work with published parameters in the upcoming exercises here. So what are parameters? What are these parameters that I've mentioned a few times here? Well, you might be familiar with them, setting them on readers, writers, transformers. There are these different hierarchy, the different level. We have workspace parameters, which can be set in FME options. We have the reader and writer parameters. We actually have feature type parameters, which can be set, and we'll be interacting with those, as well as parameters for the features themselves, setting them with transformers. So now we have the concept of publish parameters, and those come into play here in under the user parameters in the navigator window of FME Workbench. So you'll notice here I have 3 publish parameters. So if I came into my job in FME Server, I'll select the job submitter. We'll see that I have those 3 parameters available to me. I can select my source, I have my feature types to read, and my destination folder. When I have the data download service selected, we only have the 2 available to us. Notably, the destination or output path is not available. As I mentioned, using the data download service, we're just writing to a temporary location to provide the compressed data set for us. So these published parameters are automatically created when we add the reader and writer. We can reorder them, remove them as we see fit. As well, if we're working with any transformers, we can actually create our own published parameters so that we can interact with them in the FME Server web UI or any other client that interacts with FME Server. Right, so here in the training manual here, we mentioned published parameters are commonly used to set such things as coordinate systems, what feature types or what layers. We can even use published parameters to define geographic area of interest. That is exactly what that demo I showed on demos.fmeserver.com was doing. It was grabbing with JavaScript our most clicks on that map, converting it from local coordinates to a geographic coordinate system, and then using that as a clip on a larger data set to provide that small output file. And then, yes, of course, any other reader, writer, or transformer parameter. Any parameter you see in the canvas, in most cases, well, I'll say 99%, can be set as a published parameter. Right, this is a keyword here, flexibility. That's exactly what published parameters give us. It gives us the flexibility to create one workflow, but have it do multiple things for us. So here on this next page here, we're just highlighting in the navigator where these published parameters are. We have parameters available on the readers and the writers. They can be linked to published parameters. There are parameters for the feature types down here, and then of course for the transformers. So if I'm interacting with any of these, parameters in the navigator window, I can very easily create a user parameter out of them by just right-clicking and selecting Create User Parameter. In this Add, Edit User Parameter dialog, I can actually specify whether it's published or not with this toggle. If I have an unpublished parameter, then I'm not going to be able to see it in the FME Server web user interface, as you may expect. And also we have the option to set whether a parameter is optional or required by unchecking this box. We have further customization available by editing the prompt, configuration, and you can see that there is quite an extensive list here of parameter types. So if you're an FME Workbench guru, then you've probably used quite a lot of these. Maybe not scripted TCL though. I feel like that's a dying breed, but still important. Laura, have you ever used TCL?
No.
No, I've never used TCL either. Was it
Yeah.
transmission control language or
I have no idea.
something like that?
Yeah.
We have to have a working knowledge of it, as you might say. Right, so some key parameter types that we will be using in this training course include choice with alias. That allows us to just give a display name, kind of a user-friendly display name for an end user, and then in the back end, we're actually specifying a value. This is particularly useful when you're interacting with APIs and you're creating parameters in a workflow that will actually populate those parameters, but a lot easier if it's a user-friendly display name. And then I mentioned we do have scripted parameters like TCL or Python. So we can leverage existing scripts that we may have created or that you may borrow from such places as Stack Overflow. So we can just simply copy and paste these into a parameter. So I'll just give an example here. So see, I would just come in here and I'd throw in my Python code. In here, you can see that it's going to run against Python 2.7. Of course, that's a workspace parameter. We can change that now to 3.4, 3.5, or one of the Esri Python libraries, if we have those accessible to us. And so by running a scripted parameter, we can often get a little bit more information into that value than we could with a typical or more common type. So that brings us to exercise 2, the continuation of this data download system. Now we're going to incorporate some published parameters into our FME server workflow, and we'll do that by editing our FME workspace. So if you have already been following along, you can continue working in the same workspace. If not, you can open up this start workspace here that we've created for you. So the only thing that I had set in here was the parameters for the raster resampler, and that was the cell size, the spacing. So let's actually give the end user who's going to be interacting with this data download system the ability to work with these parameters themselves. So if I go in the navigator window under user parameters, publish parameters, I'm going to right click and go add parameter. And I'm going to set this to type number, and we'll call this cell spacing. It is going to be published, and we are not going to make it optional. We're going to make it required by unchecking this box. So the idea here is that our end user will be able to define the resolution that they want the data to be presented in. So if we come into the configuration here, we can actually set the lower and upper limit for the numeric value that allowing us to set that upper and lower limit ensures that we can kind of protect the end user from producing data that just doesn't make sense. So my lower limit will be greater than 0, and my upper limit, for the purposes of this exercise, we're going to set it to less than 51. So we'll have a 1 to 50 values of 1 to 50, and we can ensure that it must be integers by adding a 0 for the decimal places of precision. We also have the option to set a default, so let's do that here by setting default to 50. And new for FME 2017 is this attribute assignment dialog. There has been a lot of confusion over this attribute assignment option. It's always been running in the background, so it's not a new feature, rather we're exposing it. So the default is the default, and what is the default? Attribute assignment allows you to set an attribute as the value for this parameter. If we set it to off, then we can only manually enter in values. The advantage to setting an attribute in its place is we can have the value of the parameter dynamically set by the feature type that passes through it. For our purposes, we will not be interacting with this attribute assignment parameter itself, so we'll just leave it as default. But just to note that it is there now. There is documentation available if you go to FME Workbench help at docs.safe.com. So now we've created that user parameter, let's apply it to this raster resampler transformer. I'm just going to go into my parameter editor window, and for the X and Y cell spacing, I can select that cell spacing user parameter. And for this purposes, we're just going to set it for both, so that means we're going to only ever be defining squares here. That's fine for the purposes of this exercise. So hit apply to make those changes. So one other thing that we can do with this workflow is to not only define the resolution, but we can also give the user control over compression. So let's do this by creating another user parameter, and then we can assign this to the JPEG writer. So if I come in here, I actually have the ability to define a compression level. Now I could come in here and create a user parameter, but if I do it this way, I'm not able to change the type of user parameter that it is. It's just going to create this numeric type parameter. So in order to set this as a, rather than enter anything you want, let's give a restricted selection. I'm going to come in here and create a new user parameter. So this exercise demonstrates how we can use the choice with alias. So that is the choice with alias type. Make sure you do not select the multiple. And the name of this one is going to be compression. Will be published, and again, not optional, as we need this value set on the writer. So the prompt we'll give our user is select compression level. And the choice with alias, if I click the ellipsis for the configuration, you'll see I'm going to be defining a finite discrete amount of values. So those values will be 0, compression, 25%, 50%, and we'll also give them 75%. So these are the values that will be passed to the writer. These integer values required for the writer, but the alias allows us to define more user-friendly compression levels. So let's enter those in. None, low, medium, and high. Just following along here, I'm on step 4 in the training manual. So I'll click OK to close that, and OK again to close this box. You'll notice here I'm not going to set a default value, so that's going to force the user to set a default when they run it for the first time. So again, I've created this user parameter here, but we need to actually apply it to the writer. So if I'm in my parameter editor window here, I'm going to select the contextual menu here for compression level and set it to my compression. I guess I have to click off and on to refresh that list. Here it is. I'll hit apply. So now when I run my workspace, I'll be prompted to set those items. We can test this out in FME Workbench. First, I'm going to save this file, save it as exercise 2. And then if I have my run with prompt selected, then I'll see I have my source file, the feature types, the destination. I can set my resolution. You'll see if I try and set it to something that's invalid, I get that nice red box. Again, if I try to set a float, it's not going to like that either. I'm required to enter an integer. And then I have my drop down here to select my compression level. So let's make sure that runs here. Translation successful. And I can see that 938, I've just overwritten my image that was previously created. Because of my compression level, now we have this super pixelated image here. If I were to blow it up, looks like a thumbnail almost. So because I've modified the publish parameters for my workspace and FME Workbench, I no longer have the option to republish to FME Server, even though I'm in the same session. So I must go through the same publish wizard, but I can basically next through everything here. There's my fun little tired FME Workbench. We'll just pop that back up. Pretty sure my workspace did publish here. We can verify on the web UI. Yes, it did. So there I have my parameters now here. You might notice here that, hey, I thought you didn't specify default value for compression level, and that's true. However, when I ran it in FME Workbench to test it out, I was forced to specify that compression level. Once I specified that compression level, it actually had set it in the publish parameter, which of course wasn't saved because Workbench crashed. But that's why we see this compression level here. So if I run this workspace, set my parameters, and then publish, those will be the parameters that are set as the default. So that's something to be aware of. If you have default in mind, make sure that when you publish to FME Server, that you see that reflected here in the navigator window. So let's maybe give this low compression, lower resolution. This is a data download service I'm running here, so I'll be presented with a zip file. And then we can see now through the use of publish parameters, I'm able to get a different output image now because I've configured my workspace to have that flexibility. All right, so that concludes exercise 2. Looks like I did everything there. So on to format and coordinate system selection. So I mentioned that these are 2 valuable ways that people will leverage publish parameters for, allowing a user not only to select a coordinate system, but also to select a format. These are both items that can be parameterized. So to control format, we actually use this generic or any format writer in FME. And this writer simply has a parameter which controls the format of the data. So we can actually use this generic writer and specify a set of different formats that the user can write their data to. So in our data download system, we're currently using the JPEG writer. However, we could use a generic writer and provide the option for an end user to not only write to JPEG, but maybe keep it in GeoTIFF, maybe also PNG. Of course, you'll have to be aware of the different formats with the data you're working with. Obviously, you couldn't give if you're working with raster data, we're not going to want to throw in a text line writer. That's not going to be very legible data set that's created. Yes, the training manual notes here that keep in mind that each writer has its own specific parameters, and they still may need to be set. So for our JPEG writer, you may recall that we have this compression level. That's unique for a JPEG writer. Not every raster format has this option. So we'll see that using a generic writer will not completely replace this JPEG writer in our workflow. They'll actually be both present and working together. That's just something to be aware of for any type of format. If you want to specify the parameters of that format, you must also have the writer to work with. And we'll see this in the upcoming exercise. Coordinate systems, again, very valuable to allow someone, user, to define which coordinate system they would like their data to be reprojected in. We can either use a parameter created right on the output data set here, or we can use one of our reprojection transformers available in FME and parameterize the destination in there. So for example, the CS map reprojector, which is probably my favorite one to use, we can actually specify that destination coordinate system. We can create a user parameter here, or we can do it on the writer. Depends on the level of flexibility that we want. The CS map reprojector, of course, allows us to define geographic transformations and vertical handling. Some cases that might be necessary if you're working between, say, CSRS and NAD83, for example. So again, you can use this choice with alias, which is particularly useful for coordinate system. If you've ever had to type in a particular coordinate system in FME, you know that when we start typing the coordinate system here, it is in, this is like the particular value that we need for the backend transformation to generate, but UTM 27-1 might not be as informative that we might want it to be for an end user. So we'll be able to use the choice with alias and still have a coordinate system parameter here. So in the example here, they are using choice with alias for defining a writer using the generic writer. And then we can specify the user-friendly map info tab. And in the back end, we're actually passing the value MI tab to our writer so that it knows the correct format. So that here in the web UI, the user is presented with that instead. So now that brings us to exercise 3, where we will be creating parameters for the format and coordinate systems. Again, expanding on the data download system that we're creating in FME Workbench. So if you've been following along, you can continue with the exercise 2. If you're just joining us for this exercise here, feel free to open up this begin workspace and you'll be in the right spot to continue. So to give control over the format that we're writing to, we need to add this generic writer. So I'll select my generic writer here from the QuickType. And for the writer dataset, I'll just again write out to my C FME Data 2017 output folder. There we go. Having a little bit of delayed key typing here. Opening up my parameters, we can see that there's the red exclamation. That means there's something for us to set, and of course, that is the output format. So right now, I'm going to set this to be JPEG. Make sure you select the first one listed here, not JPEG 2000. And I'm also going to set my MIME type here to be image/JPEG. So we're just setting up this generic writer right here, and we'll be configuring it to write to different formats a little bit later on. For now, let's also leave the feature type definition as copy from reader. So you should have, again, parameter set to JPEG, MIME type image/JPEG, and then we can hit OK. Okay, so now we have a little bit of an ambiguity here in our workspace because we had copy from reader. We're just reading that 10607 feature type, so these are actually both listed the same. So I'm going to go ahead and create an annotation here. So now I know this is my generic writer, and I'm going to create one here, add annotation, and now I know which is my JPEG and which is my generic. So we want to actually write out to this generic writer, so let's switch this stream here to the generic writer. Oh, you know, one thing I didn't note, if anyone hasn't used FME 2017 before, you'll notice that now we have this nice like wavy connection lines here. So under the view menu here, you can go back to your straight lines if you'd like, or you can even now select squared lines. That's your thing. And now we have curved lines here. So feel free to create some FME art in your workspace. I've seen some pretty interesting things that people have done. I think one of our colleagues created a fish. Was that Dimitri, or is that someone from the community?
Oh yeah, it was Dimitri. Yeah.
Dimitri, yeah. If any of you have ever had the opportunity, the privilege to see a presentation by Dimitri Bag, he's excellent with rasters. He famously did our Minecraft stuff. He's done some really cool stuff with presentation, and I think it's probably on the Knowledge Center. If you go to knowledge.safe.com, you could probably find it somewhere on there. Anyway, back to the exercise here. So we actually want to have the user control which format we write to. So we've added a generic writer. We've set it up for the JPEG because we need to satisfy the parameters of the writer in order to add it to our canvas. But let's actually create that user parameter for the user. So if we right-click on user parameters here, let's add a new parameter. This is going to be choice of alias. And we'll call this output format. We want this published and definitely not optional. And the prompt will be for our user to select the output format. Click on the ellipsis to open up the configuration menu here. And does everyone know the values that we need to enter? Well, I don't. So it's pretty handy that we have the ability to import from either dataset coordinate system or the formats list to actually populate here. So let's import from writer formats. And now we don't need to worry about the short name or the description. That can automatically be populated for us. So the 3 we want to give the user is GeoTIFF, so select that. JPEG, again, not JPEG 2000. And PNG, so that's the PNG raster, not the rasterizer vector format. So I'll click OK. Now you'll see that automatically populated. We have our FME values and our user-friendly values here. So again, we'll leave the default. When we run our workspace for the first time, we'll worry about populating it then. At this point, I am going to go ahead and save my workspace. My FME workbench has not been my best friend this training course. So let's make sure that I always have my work saved. Right, so we created a user parameter, and some of you might have even noted that, hey, look, there's already a parameter created for us. And that's because when we add readers and writers, we do automatically create a publish parameter for the source and destination data sets. The generic writer is, of course, a special case where we have an output format parameter. So let's change that over, and we can do that in the navigator window here. So if we go to the generic writer and make sure the parameters are expanded, we can see that the output format is linked to that generic out format generic parameter here that was automatically generated. But we can right click here and link it to a different user parameter. And let's select the output format one that I just created, that choice with alias parameter. And just like that, you'll notice that the generic out format generic parameter is removed, as it was an automatically created user parameter and it's no longer referenced anywhere. FME recognizes it is no longer of use, so it automatically removes it for us. And you notice because I did not set a default for my output format, the parameter itself is red, and when I run my workspace, whether I had prompt on or not, it would bring up a dialog for me to set this output format parameter such that the translation could run. Nothing to worry about. Once we run the workspace, we'll set it then. So the next parameter we'll create another choice with alias to give our end user the option to select a different coordinate system. So again, right click on user parameters, add parameter, type choice with alias. And this one, let's call it output coordsys. And again, this is published and we do not want this to be optional. Prompt our user to select the coordinate system. So if we click on the configuration here, again, we don't need to know ahead of time which value FME requires. We can simply import from the list of existing coordinate systems. So I know that this data is in the Vancouver area of Canada, so let's select a few coordinate systems that are applicable for this area. Notably, let's do the BC Alberts. So we can search by EPSG number. So I'm going to select this first one here, BC Alb-83. The next one I'm going to do is 4326. That's our lat long 84. And also UTM 83, which is 26910. And we want this one here. So with those three selected, I'll hit OK. See those now populated here. And we can hit OK to create that parameter and OK again. Again, we don't need to worry about defining default. We'll be prompted for that. So in the similar fashion for the output generic writer, let's right click on the coordinate system and link that to the new parameter we've created, output coordsys. Again, we have the option to specify this on the writer. If we wanted to, we could have used one of the reprojection transformers and done it that way instead. All right, so save that. And I'm going to publish this up to FME Server, selecting my connection credentials I've created, and into my training repository. Again, not uploading any data files. So I can't just, I got to make sure to look at the data download properties here. I can't just go ahead and publish because it's still set for my JPEG writer. We actually want now to specify instead the generic writer. So I'm unselecting JPEG and selecting generic. And I'll go ahead and publish that. You might ask, why did we not delete this JPEG writer? That's because this JPEG writer is now kind of sitting here as like a dummy writer. It's allowing us to still specify our compression level through a publish parameter, even though all the data processing will be running through the generic writer. When the JPEG option is selected, we're still going to be able to pick up on that compression level. I'll go to my main web UI here, and I'll see this in my recently published workspaces. So now when I select my compression level, I'll select my output format. Let's do PNG, and I'll throw it into UTM. One thing to note here is, of course, this resolution parameter, it's only, this compression level parameter is only applicable for the JPEG writer. So, of course, the publish parameters aren't smart in that sense that I've selected my PNG writer. The compression level is now not being used. So this is something you could have maybe indicated here, like JPEG only. So I'm going to run that workspace. Did not test it in Workbench, so fingers are crossed. Successful translation, that's great. And then I have my output results here. Let's verify that a PNG file was written in my output folder. And yes, it was PNG image. And again, super small. So that concludes exercise 3. We've taken our data download system. We're converting from GeoTIFF to JPEG. We gave the user the option to specify resolution and compression level, and we took it a step further by defining a subset of available formats to write to and coordinate systems, and presented that as a publish parameter so that the end user has control when they're interacting with FME Server via a client, such as the web user interface. If we were working with a custom web page or any other application, all these publish parameters would still be available for us to set. So we'll be continuing on with self-service with FME Server Part 1. And the next section we'll be working with layer selection and handling. Throughout the exercises today, when I've been running my workspace in FME Server, you notice we have this feature types to read parameter, which up until now I've been ignoring and have not addressed. So that is what we will be doing with this section and the upcoming exercise. So in FME, we refer to layers as feature types, and we have some flexibility we can introduce through that feature types to read parameter. So when we have data sets that have more than one feature type, such as depicted here with this community map, we have a variety of different feature types or tables or layers that we can read into FME. An advantage of selecting layers is that we can limit the number of features that FME actually reads. In some cases, increasing our performance by reducing our processing time. So the feature types to read also has a published parameter, but notably this parameter is a lot different than any other parameter definition and is unique for feature types. So we'll look at that in an upcoming exercise in a little bit more detail. We also have the option to combine layers into a single selection. So using the alternate display name in a feature type parameter, the example here has presented a display name of roads for the end user, but in the back end, we're actually going to be selecting 3 unique feature types with this one public-facing selection. And that's just a shot here in the web UI of the option to select roads. We don't see residential, secondary, or arterial. They're all selected with the single selection there. So let's continue on with our data download system in exercise 4, and we'll incorporate layer selection into our workflow by authoring that workspace in FME Workbench, and then we'll publish it up to FME Server to see how now we'll have this flexibility. So the idea here is maybe one of the frequent requests we get is not only to provide this raster, this orthophoto imagery, but maybe we also want to have our street network overlaying onto the image, and that packaged up in our output presentation image, the JPEG, the PNG, or the GeoTIFF. So we'll add some additional logic to exercise 3 and allow us to work with the feature types parameter. So if you've been following along, continue on with your exercise 3, and if not, we have a exercise 4 that you may begin with. So the first step we'll do is to actually add a data set where we'll be able to leverage the use of the feature types published parameter. And that one is going to be a MicroStation file. So I'll do a quick type here. And the one I want to select is the version 8 of Bentley MicroStation Design. And to select the data set, I'll hit the ellipsis here, navigate to my favorite folder of the week. In data transportation, I have a roads DGN file, which is the road network for the city of Vancouver. I'm going to open up the reader parameters here, and I want to make sure that I'm grouped by level names. So levels are referring to the layers or the feature types in the DGN file itself. Excuse me. You'll see that we have a few other options available to us here, but level names will allow us to select the kind of user-friendly network names. And again, we want to make sure that we select single merged feature type. And that's because we have multiple source layers, and we don't want to create an individual feature type for each. An individual feature type for this data set would produce multiple readers on the canvas. We just want to have that single merged feature type, one reader on the canvas here. So there we go. Again, what's really handy to do is we can just attach some annotation here. I know that's my GeoTIFF writer, and I'll attach annotation here. I know that's my DGN writer. Just giving me a little bit better visibility on what's going on in the workspace here. So we have a workflow where we're dealing with all this raster data, and now we have this vector data coming in. So let's mesh these two together with none other than the vector on raster overlayer. So one handy thing in the quick type menu is we have all of these transformers and readers, writers, and title case. So you can actually just type in the capitalized letter for each. And that's why I type in Voro. Not only do I get all, of course, my Voronoi transformers, but my vector on raster overlayer. So I can connect now my vector data here. And as well, we want to have our raster data now going in to this transformer first. And you might remember I can keep my lines from being crossed by changing the order of ports on the transformers. And now this vector on raster overlayer transformer outputs a raster. Let's connect that back up to the generic writer there. For now, we will leave the parameters as is. And let's focus on creating the user parameter to allow us to select the feature types to read. So under my user parameters here, I can either create a new one there, but let's go to the DGN reader in the navigator window, expand the parameters for the reader, and let's expand feature types to read. This is where we'll see that feature types to read user parameter that's been created. And that's created automatically when we add that reader. We right click to edit the parameter, edit the user parameter definition. And this is where now we'll import the list of features to use. So we want to set a fixed list, and we also want to use an alternate display name. To import all the feature types that are available, let's click on the list down here, and we can add from current data set, because of course we just have the one feature type here. Let's get them all in. So it examines the DGN file, reads in all of the feature types by level name. And we can just select all. So now your display window or your dialog window should look similar to here. We're required to define the display names for the new imported feature types. So we could leave it without an alternate display name, and then the user could select individual layers or multiple layers themselves, but let's kind of package these up a little bit easier for our end user. So following in exercise 4, we have a table here. Step 5, I'm going to be matching my display name to these feature types as listed here. So for arterial, that's my primary road. My collector is also a primary road. Non-city, we're calling other roads. Other, you've guessed it, is an other road. And then private, again, is other road. And then secondary, we're going to group with residential. We'll call this secondary roads. And we'll switch the residential display name as well. So now the end user will have 3 choices: other, primary, and secondary. Give that a quick spell check there. And then once I have that once you have yours matching here, what's displayed in the exercise manual, training manual, we can hit OK. You might also consider changing the prompt here. Feature types to read. Again, this terminology that we're using within FME. If your end user is more familiar with levels or tables, you might wish to change that. So let's just call this vector roads to overlay as suggested by the training manual. Overlay. And again, we will not worry about selecting any default value. So now I'm going to save this workspace. This is exercise 4 we are on in chapter 2. And now I have this parameter in here. So we do have quite a few parameters in here, 10 published parameters. We can start to clean up this a little bit here for our end user. We're not using feature types on the GeoTIFF. Not yet. We will be configuring this upcoming, so we will address this parameter, so we can leave that in for now. But the source data sets, we know those aren't going to change, so let's remove the source for the GeoTIFF, the source for the DGN, as well as the destination data sets. We're working with data download here, so we're not really worried where we're writing the data. It's always going to be that temporary location. And then we can drag to reorder these parameters, and that will be reflected in the web UI. So let's have the user select their output format first, then their spacing and compression, their output coordinate system, and then they can select the feature types as well. So maybe we'll drag that one up there because that's kind of a couple of the most important ones here. So this source raster file here, this feature types to read, like I mentioned, we can address that now. When we first added this GeoTIFF reader, we selected that single merged feature type. Now that might not have made sense if we would only be working with that one GeoTIFF file, but now that we've selected that single merged feature type, it gives us the opportunity to define multiple feature types or multiple files, multiple rasters that the user can work with. So under the navigator here for my GeoTIFF reader, let's edit this parameter value here, and we can see that just the one source file is selected. Of course, that's what we specified when we added the reader. Let's open up the file browser here, and we should still be in this ortho photos folder. Let's actually select all of these. So I'm doing a little Control A. Now I have all these file names selected here. So normally this would mean if I selected all these files, every file is going to be read into the translation. But this, the feature types to read parameter will actually allow the end user to define that. So I've selected every GeoTIFF that was in that ortho photos folder, and I'll select OK. And you'll notice here that now the name of the reader has changed to reflect that. So the feature types to read, when we added this reader, we specified that the feature types are going to be coming from the file name. So this feature types to read parameter here, user parameter. If we edit the definition here, now we can actually specify all those ortho photos. So we'll be able to select a subset of all those orthophoto files using this feature types to read parameter. So again, let's select fixed list, and we can add from current data set to update this list. and it's reading all those feature types. It's using the file name as the feature type name. And we'll select all of these. So these are all our physical files, our raster files that are in that orthophotos folder. And then again, we can make the prompt a little bit more descriptive. We can say raster tiles to read. Because again, feature types is terminology we're using in FME. It might not match what your end user has. So there is a warning here in the training manual. If you had not selected to read your feature types from file name, then you probably only have a single option called GeoTIFF. The easiest way to get around that is to open up the completed workspace for exercise 4, or you could re-add your GeoTIFF reader. I'll save this exercise and publish it up to FME Server. So a couple things to note here. Because we removed that source dataset parameter for the GeoTIFF and GGN, at this point, if we were working where our orthophotos were not located on the same file system as FME Server, then that parameter would, of course, allow the user to upload the file so that the workspace can run. So now, at this point, it would probably be a good idea to upload our data files so that we can ensure that the data that we want with this translation is going to be pushed with that workspace. So for this exercise, I will upload all my data files. Again, because I'm working all locally, it's not necessary for this training exercise, but I will do that. Just make sure that in your data download properties that your output generic writer is selected. And we can publish that to FME Server. And then you can see a file transfer for all these orthophotos. Again, we have entire FME Workbench. But what I do want to mention is that we're uploading all these files with the workspace. They're being deposited into that workspace repository. So if we were planning to use these raster files elsewhere, that would not have been the most ideal option. We probably would have wanted to upload them to the one of the resources folders, like the resource data folder in FME Server, or we might wanted to instead reference via a UNC path. So I have my exercise 4 workspace here. And you can see now parameters are looking a little bit cleaner here. Definitely a lot less to worry about. So the first thing I'm going to do is select raster files to work with. So I'm going to select a bunch of these 0607s. So you can use the filter option after clicking, and the list gets shorter and shorter as I enter more and more. You can select as many as you want or different ones. We still have our option to select our output format. I don't think we've written to GeoTIFF yet, so let's do that. Now we can select which roads. Let's maybe do primary and secondary roads. Let's put the resolution to an average value here. Compression level, again, isn't going to affect the GeoTIFF writer, but it is also a required parameter for my JPEG format. So I'm just going to make sure it's populated. And let's have this right to the Alberta's equal area coordinate system. So just as an example here, I'll show you the advanced parameters here. Now, you can see that my direct URL has all of these extra values and parameters specified now, so I would be able to just use this URL in a web service if I wanted to. and again, just the summary we have here of published parameters. So I'll kick off my data download service. And that was a pretty quick translation there. And I'll just verify my output files here. So I have my geotiff file, and then you can see here I have a few different very low resolution ortho photos that have been stitched together. This is the 0607 swath, I suppose. And we have my primary roads, these vectors in red, and you can see the pixels of my secondary roads here in white. Maybe I'll try running that one again here. I'll just use the back button, and that was a lower resolution. Is that going to give me a big image, or am I going backwards here? Luckily, my FME server is super powerful. We'll run this workspace again here. Looks like it's generating a much larger file based on the time took there. Yeah, so now we have a 14 megabyte file, and we have much cleaner looking orthophoto imagery. I got to actually zoom way in so I can see my primary vector roads in red and my secondary in yellow. So that concludes exercise 4 for self-service with FME Server. We took that data download system and we added that additional functionality to allow the user to read specific raster tiles. You can stitch together whichever one they want. And we also added a new data set and some logic so that we can actually overlay the vector features onto our raster tiles using that vector on raster overlayer transformer. So we do have a couple troubleshooting tips here for the data download service. And we'll just do a quick review. This module, part 1 that we've completed. We'll continue on with part 2 as we still have another 20 odd minutes in today's session. So the key points here are that services handle communication between FME Server and its clients. So those are the transformation, utility, and notification services. We interacted here with the data download service directly. Yesterday, we were passively working with that data upload service that was chugging along in the background when we were uploading files with the publish workspace and also in the resources page of the FME Server web user interface. Using the data download service presents the end user a link to a zip file of the output data set. The data download service does not require use of the destination dataset parameters as it writes to a temporary location that is cleaned out on a schedule defined in the system cleanup page of the FME Server web UI, which often is more of an administrator's task to worry about. We can use a variety of different parameter types to control and enhance flexibility in our data download service. We looked at choice of alias, setting a number parameter using a low and high end cap for the values that are acceptable, as well as using feature types to read coordinate systems and format type. Generic writer has its format defined at runtime via a parameter. And we can also leverage the traditional writers as a sort of dummy writer so that we can set our format specific parameters, in the case of the JPEG, the compression level. So at the end of each chapter here in the module review, we also have some suggested articles in further reading to kind of enhance or round out your FME knowledge, I encourage you to check these out at some point, whether briefly or in depth. Some of them are blog articles and some of them are Knowledge Center articles. And the link to the Q&A at the end here. So we'll continue on here with the self-serve with FME server topic. And let's look at the geographic selection that we can provide for a user. So again, if I go to here to demos.fmeserver.com, we can see that we can create this data selection, allowing a user to draw a polygon. So we need a way to read in these coordinates or maybe predefined bounding boxes or areas of interest for a user to work with. So geographic selection, yes, can be through a simple rectangular bounding box, this ad hoc boundary area, which we're drawing in that demo. Or we can use an existing boundary by reading in a feature. Maybe we have a file defining certain geographic neighborhoods or zones, whether you're working with maybe like wastewater, you might have different zones there. So bounding box or this search envelope is available for every or for most of every reader in FME. So on the reader parameters here, we have under the parameters, we have search envelope here. And that's where we can predefine a clipping area. So in the case of the demo, we're likely using a JavaScript to take in the user clicks, and then we take that box that's created and we're passing it into the minimum X, minimum Y values here. Something that's very interesting to note, we can actually work with a different coordinate system for our search envelope. So our data set, our source data set can be in one coordinate system, but we can actually have a user define a search envelope in a particular coordinate system. This is useful because maybe in this web map, for example, we're using Google Maps here, so everything's in lat long 84. So we want to make sure that when our search envelope is defined, that we're actually specifying, okay, look, this is a lat long 84 coordinate, even though our data set might be in UTM 83. And then, of course, flexibility to reproject within the workspace and provide an entirely different coordinate system if we wish. So this clip to search envelope parameter here, we just know in the training manual, if it's set to no, then any feature overlapping that boundary is included in its unclipped form. So if we don't clip the feature, of course, the entire feature will come through. If we set it to yes, then we will truncate the feature on that boundary. So the bounding box parameters are particularly useful when we're working with web mapping clients such as Google Earth. And we can have published parameters that specify these bounding boxes. For the KML, in particular here, we have some predefined names for the published parameters so that in the KML network service, it's automatically populated into that format. So that's bounding boxes. We also have the ability to select existing boundaries. So in the two images here, we are bringing in garbage schedule, which is divided up into zones and subzones. So we can use maybe a test filter here where we can have a user parameter to define which zones we want to read in. And there's a couple ways we can actually select from existing areas. One is to use a where clause. So available on some of the readers and writers, like the database format here, file geodatabase API. We can use a search envelope here, and once we actually add the reader to our workspace, we have another option to specify a where clause as part of the file geodatabase API reader parameters. So we have the search envelope as one option, the where clause as a second, or we can use a transformer such as the tester or the test filter. Using the transformer method wouldn't be as efficient because we'd still be reading in, note here, all 6 features on this garbage schedule data set. But if we use the search envelope or if we use a where clause, we can actually limit the features read into FME, decreasing our processing time. There's also the feature reader transformer, which allows us to read data in mid-translation. And the feature reader transformer, you can actually have a spatial filter. So we can actually pass in a geographic feature in our FME workflow into the feature reader, and that will or could define a spatial filter using all these standard JS operations. So for example, here I could have my Esri file geodatabase, and I could pass in maybe my geotiff stream, and so that those geotiff files would define a geographic area, and then I can use that as maybe an intersect, so that only features from my geodatabase API that intersect all of the incoming features from my geotiff, my raster tiles, only that area would be read in. So that's a fourth option there. We have our search envelope, we have our where clause, we have our tester or test filter transformers, or we have the feature reader transformer here. The tester or test filter still requires you to read all the data in, but the other methods allow you to just grab that subset of your data. And in the training manual here, we talked more about the feature reader transformer here. Again, that's the idea here. We're passing in a spatial feature, and that becomes our clipper in the feature reader. Oh, and that was a perfect segue right into the clipper transformer. Another option you can use is this clipper transformer. Again, you're going to be reading in all your spatial data, but you can use that clipper transformer to filter the area of interest. So here we have a garbage zone coming in as our clipper, and then we have all these postal addresses, almost 14,000, but we're only going to continue the workflow with the postal addresses that are within the specified garbage zone. So it's kind of a partial performance saver here. We do have a where clause, so we are limiting our garbage schedule, but then we're reading in every postal address and only later clipping. So in general, you should be doing all your clipping, all your filtering of features like this at the beginning of your translation, so that we don't have to do redundant processing on your features that you're just going to be throwing out later on downstream. So for the ad hoc boundary, I guess that's more what we've been drawing in the this polygon here. That's what we call our ad hoc boundary. FME can interpret well-known text and XML. So we can pass that string in as a published parameter, and using a geometry replacer transformer here, we can convert that text string into a spatial feature, and then now that spatial feature in this example workflow here is being passed into the feature reader. So there are definitely there's more than one way to skin a cat with FME. There's always more than one way to do a certain operation. So you have quite a few different choices, whether it's a boundary, a predefined boundary with an existing feature, or maybe a list of predefined boundaries, or if you're going to let your user define their own boundary. The choice would be up to you for the type of workflow. So it's 10:48 a.m. We have just about 10 minutes left in today's session. I think this is a great spot to end today. It's a lot of information here we've done with the self-service with FME Server. We'll continue on tomorrow with a short review of geographic selection, and then we will continue working with our data download system, and we will see how we can incorporate geographic selection into this workflow. We will do a quick review of where we got up to yesterday in the second part of self-serve with FME Server as the geographic selection. But first I wanted to just take a segue back to the FME Server playground and take a look at one of these demos here, the real-time data validation and display. So this is a custom web page that's set up. Of course, FME Server is running in the background. What we have here is the ability to upload a data set, have that data set processed by that utility service. The data upload service runs a workspace in the background on FME Server, and then using the notification service, which we'll be getting into in the next section, leverages WebSockets in order to update our map display here. So for this example here, it's set up so we can download some CAD data. So I can do that, hit next step. So trying to copy that here. So this exercise also uses the email publication. So we have FME Server watching this email address, and I'm just on another window here configuring an email here so I can send it to that email address, attaching that CAD data file that I downloaded. And once I send that in, then FME Server will receive it. It will trigger a notification that will run a workspace. That data set's passed on into that workspace. Once that is complete, the notification service continues. And then using WebSockets, we update a database and also update our display here. So the email is just about to send. See how long that takes. So I'll let this run in the background here because the polling interval could be up to 60 seconds. So we won't just sit around and watch the screen. I'll come back to this page so we can see how after sending an email to that this FME cloud instance, we have a notification service that's waiting on the back end, ready to process that data. So at the end of yesterday, we had completed part one of self-serve with FME Server. We looked at the data download service. We looked at published parameters and creating a more flexible workspace for our end user to interact with, particularly format, coordinate system, and layer selection. So the next item we were going to implement in our data download system is this concept of geographic selection. So we again have choice by bounding box, and we have choice by existing boundary, and we have the ad hoc kind of draw it yourself boundary. And then we did a quick review of the various ways how we can limit the amount of features read into a workspace. That's of course with the where clause, using the tester transformer, using the feature reader, or the clipper transformer. So let's take a quick look here. So it doesn't look, okay, no data yet. We'll check on that later on. So we'll start with exercise 1, data download system geographic selection. That's in self-serve with FME Server part 2. So we're going to continue on with the previous workspace, and I'm going to start off, since I've closed all my workspaces here, I'm going to start with the self-serve 2 exercise 1 begin. So that's in the handy C FME data 2017 workspaces server authoring, and then self-serve 2 exercise 1 begin. So we have our familiar workspace here. We have our DGN, which I can tell because we have this nice annotation here. We have our GeoTIFF reader of our ortho photos, where we resample and mosaic them together. Then we have this vector on raster overlay. That's, remember, we're taking our primary, secondary, and other roads, slapping them down on that raster image, and we're using the generic writer because we're giving our end user the option to choose the format. So let's start by adding a reader. We're going to add a KML reader. Right down here, a quick type menu, and the data set, C FME data 2017, as boundaries we're looking for, and the Vancouver neighborhoods. So we're going to use this, the information contained in this KML file, these polygons, as our geographic area of interest. For the purposes of this exercise, we will be leaving the workflow option as individual feature type. This select feature types dialog lists all the different tags or layers or feature types in that KML file. The only one we're interested in interacting with is the neighborhoods. So I've deselected them all and just selected neighborhoods. One thing I'm going to do right off the bat, if you recall when we add a reader or writer, it automatically adds the source or destination published parameter. So I'm going to go ahead and just remove this. We're not going to be working with this, and let's just keep that web UI interface clean. So as it stands, if I ran this workspace, every neighborhood from that KML dataset would be read. However, the idea, the goal of this exercise is we're going to prompt the end user to specify one of these neighborhoods in Vancouver. So how are we going to do that? Let's create a parameter to give them that option. So come into the navigator window, right-click user parameters, add parameter. This is a choice type parameter. And again, we just want a single choice for this exercise. And this is going to define our neighborhood. It is published, and we also will leave this as optional. If they don't select a value, then we will not clip, and every well, the whole area will be returned instead of just that clipped area. So prompt to the user, select the neighborhood. And for the configuration, we need to manually enter the neighborhoods of Vancouver here. So that's listed in the exercise guide and step 3. So we'll be entering in those items there, and I'm just gonna rearrange my windows here. If I can, all right. That's okay, because I think I know them. Got downtown. We have Fairview. It's where the Vancouver Hospital is. Kitsilano, where you can have all your yoga and green smoothie drinks. Mount Pleasant, an increasingly gentrified area of Vancouver. Strathcona, multi-million-dollar homes there. And definitely West End, where you have multi-million-dollar condos. All right, so again, I'm not going to leave a default here, and we don't need to worry about that because we don't even need the user to select a value as we've left optional selected. So once you have those 6 neighborhoods entered in, then we can hit all right, or I guess hit OK. And so now that we have the parameter, let's actually get that in a workspace. We'll use a tester transformer, one of the options mentioned yesterday. So using the tester transformer here, it is going to still read in every neighborhood feature, and we're only filtering after the fact. So that's that is noteworthy. If we wanted to increase the efficiency of this workspace, we might consider trying to limit the incoming features rather than filtering here. So we're going to set the neighborhood name. That's a attribute on the KML. If the neighborhood name is equivalent to this the value of the neighborhood parameter, then they will pass through the passed output port on this transformer. So we've been working in the projected coordinate system here for all this data, but KML is in geographic LL84. So let's make sure that we reproject this data. I'm going to use CSMap reprojector. You might ask, what are the difference between all these projector transform or reprojection transformers? And that's just the libraries underneath that are actually doing the conversions. So we want to make sure that we're reprojecting for this exercise into UTM-83. KML is a spatial feature, so we should be able to read that source coordinate system. If you ever want to verify what FME thinks that source coordinate system is, you can always open up the data set in the data inspector. Of course, we can do that really easily on the source data. And I should find here that when I select a feature, that we indeed have a coordinate system defined. I'll just double click here, scroll over. Yeah, LL84 is set. So FME will automatically read that in that transformer. So now that we have filtered, we need to actually set up this clip operation. So the neighborhoods are the clipper feature, and then the clippy will be this raster image. So we're going to actually draw the line from the output port of the raster, the vector on raster overlayer to the clippy, and then we have the inside features now passed to this generic writer. So your workspace should look something like that. On the clipper transformer, we just want to make sure that the preserved clippy extents is set to no. And that's under the raster parameters here. So it looks like mine is set up by default. So let's publish this workspace up to FME server. Selecting our credentials here, throwing it into the training folder. Just going to get rid of this begin. It's no longer the begin of the exercise. Again, for the data files here, I don't need to worry about uploading them because everything is local to FME Server. If we were working with data on a different machine connected via network, we could enter in UNC paths for every data source. And I'll show you that in just a moment here. Let's register with this, the data download. Make sure that we just have the output generic, not the generic and JPEG. JPEG's not going to return us anything. Generic's the one we're interested in. Why is JPEG not going to return us anything? Well, it's actually not connected up in this translation here. So quick note about the UNC paths when you're working with FME Server. So right now I'm logged in as just administrator on this machine, the administrator account, a default account. Say you were on your work machine, you might regularly log in with, say, Active Directory or a different account that's set up. So when you run FME Desktop, that's actually running as your user. So you could come in here in FME Desktop and type in your network drive, your UNC path, run the workspace, everything would work fine. If you publish to FME Server, then you might find, oh, hey, didn't find the data, what's going on? That is because FME Server, by default, runs as this local system administrator, which may not be configured by your IT department to have network access privileges. So I've just opened the services utility application here on Windows. And if I scroll down to all the FME Server Windows services, you'll see that the logon as is set to local system. So if I'm working with UNC data, I want to make sure that my engines are set to a specific service account. That allows the FME engine, the workhorse, what's actually processing the data, to access the UNC path. If you're working with any other services in FME Server, you should also set the FME Server core so that the notification service and such have access to those same paths. Generally speaking, it is not required to set the FME Server database, especially in an express install, as all this traffic is local. And similarly for the FME Server application server. Of course, this changes if you get into a distributed environment, but that's just something to note. That was a great question we had by one of our attendees for some clarification on that. Okay, so coming to run workspace here, I'm going to interact with that published workspace here. I'm looking for self-serve 2, exercise 1. You'll see now I have the option to select a neighborhood, so let's select downtown. I need to specify a whole bunch of rasters to read, because I don't have any defaults set up here, and kind of taking a stab at which ones I need here. But I'm pretty sure one of these will get me into the downtown area. Select all the roads this time. Run this translation. So what I should have here, my output in a zip file, is the raster tiles with the vector data overlaying, and then it should be clipped just to the downtown area. So again, that downtown area is just specified by this polygon here from the KML dataset. So let's take a quick look at that. That looks right. We're just getting that one small chunk of area here, and all the other raster imagery that was processed is just thrown out. So you could try that out if you'd like for other neighborhoods or other combinations of raster imagery. Of course, if you want to find the correct rasters, you should probably open them up in Data Inspector or the image preview application. Alrighty. So we have a few other services available to register with FME Server. Data streaming, that allows you to present the information directly back to the client being the web interface or a custom web page. It works fairly similar to the data download, where the data download is providing that URL, which is a .zip file. The data streaming actually returns the data file itself. So if I had a text file reader, it would return the text file, or we can have a JSON writer, GeoRSS. You can even stream like a JPEG image. The only limitation will lie within the client application you are using. So if we're interacting in this case with a web browser as our client, it does natively have capabilities to display JPEG and text files inline. But if you used a more complicated format, even shapefile, you're not going to be able to present that directly in the client unless you do some other configuration or the client natively supports it. So we do have a short list here for common web browsers, what formats that they can stream. And for some formats, such as the text file writer, we have the option to set the MIME type. And it mentions here that is the FME server parameter. So this is what's returned in the response headers when you invoke the data streaming service. So if your client application does not support one of these MIME types, you will likely either just be returned the file path, be prompted to download the file, or it just won't stream. So you have to make sure that if you're setting the MIME type, you have to be aware. If you do want to see what MIME type comes back, you can always enable developer tools in a web browser. For Chrome, we just have them here under options, developer tools. So you can actually inspect all the network traffic and see how FME Server is presenting the data to you by looking at the response headers and body. That does get a little bit more into the development side of things, but that is something to be aware of. And new for FME 2017 is the HTML writer, as well as these HTML transformers. Excuse me. So previously, we would use a text file writer and have to set the MIME type in that and write out some HTML using just an extension. But now we have a native HTML writer in FME 2017, where it will, with the help of the transformers, set up the proper syntax. And then you can use that in streaming. The last one here that we haven't interacted with, save for the notification service, is the KML network link. So that is a special type of service where the data set produced is a KMZ or a compressed KML file. And the idea here is you'd open that KMZ or KML in a supported client application such as Google Earth. When Google Earth opens or loads this data set, we can see in this image here, it actually has a direct link to the data streaming service on FME Server. And there is a configurable interval if you have this data displayed in Google Earth at every 60 seconds or a few minutes. Google Earth will actually make a call to that link and update the data. So you can always have a live view or a semi-live view of your data set. And then the data set is just cached locally, not on FME server. So exercise 2, we're going to take a different route here and look at the data streaming service. So we will be working with the same exercise from exercise 1 that we just completed a few minutes ago. So what we need to do now is we're not going to be able to stream this generic writer. We actually have to connect up our JPEG writer again. So I'm going to do that here. Connecting my JPEG writer to this inside stream, or the output from the clipper. And I'm just going to publish this back to FME server. Now this is exercise 2, so I'll just name that appropriately. Again, not going to upload my data files. I don't want to duplicate that data on my local system. This time I'm going to uncheck job submitter and select data streaming. There is no limitation to how many services you can register a workspace with. And just for the purposes of this exercise, we keep it a little bit more simple. So for the data download, we want to make sure that we are still using that generic writer so that when we're using a data download and the user specifies a different format, that will be honored. And then for data streaming, we want to make sure that only the JPEG is selected. So the generic writer doesn't have any MIME type set. So if we try and stream that writer, or if we try and stream multiple writers, we'll be presented with a data set to download, and that kind of defeats the whole purpose of data streaming. So by selecting the JPEG writer, that's one of those supported writers. Then I will close those prompts and publish to FME server. Guess I'm just going to have to get used to FME Workbench closing every so often when I publish. I can tell you I have not experienced this before. I hope that your machines aren't behaving the same way. So now I come to my run workspace and I'll select self-serve exercise 2, this time selecting the data streaming. And you might know that a lot of these parameters now are just going to be ignored in the data streaming service, particularly the output format is going to be ignored. So I think I'm going to use my trusty downtown neighborhood, which seemed to grab a few of these raster tiles. And so now the expectation here is that we're going to stream directly to browser. And for fun, I'm going to enable my developer tools here just so I can show you that option that I was talking about. Dock to bottom. All right. So let's watch some magic here. So the translation, we see that submitted to FME server here. And then once the translation is complete, the results should be displayed directly into the browser here, this JPEG image. Oh, it actually was downloaded, and that makes sense. Does anyone know why? That's because we have world file. So when there's multiple files in a data streaming service, the automatic response of FME server is to compress these files together. So I need to go back into my workspace here. And on my JPEG writer, there's this generate world file option. I'm going to actually turn that off. Set it to no. So now when I publish back to FME server, that world file will not be created, the files will not be archived, and I should properly get my data streaming. That's right, and that's correct. So I have my same parameter set. Let's run this workspace again. And now this time we see I correctly have streamed the same results from running that data download operation. Now that I've removed the world file creation, I just have this JPEG image presented directly in the web browser here. So if I came in and looked at the actual call that's occurring, and the response header content type is image/JPEG. So that's the MIME type that we had discussed. All right. So yeah, this is the step I missed here. Step 4 is turning off the world file when I first ran the job. So we just have a couple tips here, troubleshooting tips for the data streaming. And I think this is the most important tip here. If the output format is composed of a number of files, we just get that zip output. That's exactly what happened with that world file. So this short module here, self-serve with FME Server Part 2, we looked at using the clipper transformer to actually to clip the raster data we had to a user-defined neighborhood in Vancouver. Again, if we wanted to improve the performance of this workspace, we would likely want to limit the features entering the workspace here. So we could use either the feature reader in place of the native KML reader, or we could use, for formats that support it, the where clause. So we kind of let the database do the work there. But the tester and clipper, once the data is in the workspace, that allows us to kind of filter it down. Okay, so we will jump back into the training here and let's continue on. I will now be working in section 4 or part 4, chapter 4, real time with FME server. I'm just going to check on this real-time display. I wonder where that's supposed to happen. So never received that feature, so that'll be something to look into. I don't know if I sent it to the wrong email there.
You may have just updated the demo, so it could be the database isn't quite set up right.
Yeah, we'll take a look at that one, but that's what happens when you're off-road, I guess. All right, so real time with FME server. When we say real time, what we mean is these events happen. They happen often and they send information. Maybe they could be sensors, they can be alerts on mobile phones. It's kind of these notifications, these events that occur in real time. Real-time events are typically small amounts of data. So that is if we're monitoring like a sensor or just these mobile push alerts, like they are very small packets of information, relatively speaking. So we have examples could be location data from a vehicle tracking system, continuous stream of data from a temperature sensor or lightning detector, or a simple example such as sending an email to an admin in response to a database table update. So these are all types of notifications that occur in real time. And of course, we need to have a system to process this information. What system is better prepared than that, than FME Server itself? So real-time data is handled in two ways here: notifications and message streams in FME Server. So I'll talk on these two concepts here. Notifications are when we have discrete packets of information, whereas message streaming is the continuous flow of information. So your iPhone or Android alerts, emails, these can be considered real-time notifications, and the constant monitoring from temperature data, or these lightning strikes, if you have a constant stream open for this, GRSS, that could even be considered message streaming. So there are different processes for handling notifications versus message streaming in FME Server. For this section, we will focus on notifications, and at the end of the section, which we may investigate tomorrow, we'll be looking at a case of message streaming. So they're important to distinguish between the two. So for the notification service, this is where we're going to handle all of the real-time information coming into FME Server. And the way we handle this is by talking of notifications, or these messages, or these alerts. And notifications on FME Server can be both incoming and outgoing. So we can have a client application here that's sending a message to FME Server, so that'd be an incoming notification. FME Server has the ability to process data, to process information, and can actually send out an outgoing notification to a receiving client application. So again, we just note here, notifications should not be a continuous series of messages. If it's more than one message per second, then you're going to have to use this message streaming technique. So again, notifications, the notification service for FME Server is designed to handle events or alerts or notifications on that one message per second or slower type interval. And I'll make sure to talk on the reasons for why message streaming is a better option there. If you have any questions along the way here, please do ask, and we can handle the questions live as well. So in FME Server, this is how we have our notification service set up when we're talking about the architecture. So we have the clients, these external users or systems that can send or can receive a message. So we can see those clients on both the sending and receiving end. FME Server handles incoming notifications with a publication, and we have various protocols within. For outgoing notifications, that is the subscription, and we have various protocols there. Now, the idea of calling a publication to handle incoming and a subscription to handle outgoing relates to what is in the middle here, this topic. So the topic is a subject here that sits in between the notifications in FME Server. You can think of it as a magazine model here. So the topic gets a notification, the magazine publisher produces a publication, and then we subscribe to it on the other end. So the client, as I mentioned, can both be a receiving and a sending. So clients that send a notification to FME Server, we call those a publisher. And clients that receive a notification from FME Server we call a subscriber. Again, that's that magazine model. So to speak more on the publication here, publication is receiving that incoming notification from a client, the publisher. The client is publishing, we receive it in a publication. Yeah, the terminology can get a little silly sometimes, but after working with FME Server for a while, you do get used to it. So we can create new publications in FME Server's web interface. As well, we can create subscriptions there. There are different protocols for each, and we'll look at that here. So let's jump ahead to the protocols here. The protocol is what's actually the system in place to exchange that data between FME Server and the client. So all that FME Server is doing is we're pushing or receiving information from these services, from these different protocols. You can see in the table here an extensive list of the native publishers and subscribers that we support, as well as which protocol supports either creating a publication or creating a subscription. For the most part, they are available for both, with exceptions, of course. So some of the ones we'll be interacting with in this section will be the directory watch. We'll also be looking at email and FME workspace. And we'll also look at the logger, which is just a native native protocol for FME Server, and it's mostly, I would say, mostly used for testing. So this section here just goes into a little bit more description on the different types of notifications. So we have notifications under what we'd say watch. So that's like directory watch, FTP watch. These protocols, they're waiting for new files to appear, to be removed, or to be modified. And then we have mobile notifications. So these are available for only subscriptions, and we can send messages to Apple devices or Android devices. And then we have a variety of Amazon notifications. So that's the S3, SQS, SNS. So if you do have, if you're leveraging any Amazon architecture in your organization, you might be able to incorporate FME Server and their publications and subscriptions in your workflows. And then we have WebSocket notifications, which is this, as it says, TCP-based line of communication. And for the most part, most browsers do support WebSocket protocols, and they're helpful for sending, once we get a little bit more into message streaming is when we'll be working with WebSockets. I'm just going to backtrack quickly here to speak of topics now. So we quickly went over clients, how we can have sending or receiving. These are our publishers or our subscribers. Have the publications and subscriptions, which connect to a protocol, a service that can process or digest the information that's being passed in the notification workflow. And then sitting in the middle here, we have the topic, which is kind of like the traffic controller directing where messages go in this FME Server notification architecture. So if you want to read some examples here, you can. We just have a little bit more detail about how publications and topics are linked, and some what you might expect here. So the exercises in this chapter will be primarily using directory watch. And the idea here is that we can set up a directory watch publication on FME server. We can point it at a resource folder or any other folder on the network. And every time a new file is placed there, so maybe you have some CAD operators, some GIS technicians producing data sets, we can use it for data validation, or in this case, we'll be investigating more of a data upload type service, where any new file placed in this resource folder will be automatically processed from FME server. There wouldn't be any further interaction required for that technician or CAD operator. So now we'll be playing a lot more in the FME server web UI. The first step we're going to do is create this resource folder that we'll be watching. So I'm going to navigate to the FME server web interface, click on resources, and I'm going to navigate into the data folder. And then in here, I'm going to create a new folder, and we're going to call this building updates. So anytime that these CAD operators finish up with a DGN file, a GIS technician finishes editing the shapefile, which is shapefile is what we're going to be working with, they can place the shapefile in this directory, and then we can have FME server automatically process that. So I've got my new folder there. And as I mentioned before, if you wanted to, you could use a network drive instead, or you would be able to use an Amazon S3 bucket, Dropbox, FTP. They all have the same concepts that we'll be working with here. So now that we have a spot for our data to go, let's start creating this notification system. So I clicked on the notifications tab or button here on the left-hand menu, and the first thing we're going to do is create this publication. So we're going to call this incoming building footprints. And so now every time there's a new file, we want to notify FME server. And how do we do that? We do that by publishing this information that a new file is there to a topic. So let's create a new topic. We can do this right from the create new publication or new subscription page. So I'm going to call this topic shape incoming file. It's always handy to define in your topic name or even in your publication or subscription name what direction things are going, because we would definitely not want to end up in any type of loop by accidentally specifying like the outgoing topic for an incoming file or something. So I type that in, I can select that to create that topic. I'm going to select my protocol as directory watch. And now here we see there are a variety of protocol settings. So every publication has a different set of protocol settings. And if you need assistance on setting these protocol or setting these parameters, you can visit the FME server documentation. So I need to specify directory to watch. This is where if we were connected to a network drive, we could specify that here. But I'm going to click on the ellipsis, and that'll open my local resources here. So I'm going to go to data and select the building updates folder that I had just created. Again, we'll notice we have that FME shared resource data. That is the FME server parameter that's populated every time this publication will run. We can leave subdirectories as no. We don't want to receive notifications for folders. We're just going to be uploading files. And we only care about new files. So let's remove, modify, and delete. Now the poll interval, we can decrease that down to the minimum for directory watch in FME Server 2017, that is 1 minute. And then we can hit OK. That creates our notification. You'll notice this green circle box here, valid configuration. If we're using Amazon or email, FME Server will attempt to verify that our configuration parameters are correct. And if there is something that's inherently wrong with our configuration, we'll get a prompt right away. So let's now use the FME Server web interface to actually monitor this topic. So on the topics page here, we have this handy tool called topic monitoring. Topic monitoring is very useful, especially when you're developing a workflow, so we can see how FME Server is interpreting both a incoming message and also how it's what format it's sending the outgoing message in. It also is a sanity check to make sure that your notification service is running. So just hit the green button there to start topic monitoring, and I'm going to monitor by selecting from the drop down here that topic I created, shape incoming file. So again, that's associated with my directory watch publication. So for these purposes, I'm going to actually use a second window here. So I'm going to right click on resources to open that in a new tab. So I'll just be able to go back and forth doing some work in one tab and then coming back and checking notifications. So to test the topic, let's actually upload a data set. So I can come into my data building updates and my resources. And now I need a set of data to upload. So in my file system here, in that FME Data 2017 folder, I want to make this larger. There we go. FME Data 2017. We come into data, engineering, and then building footprints. We just have a series of fabricated examples, update examples of different buildings in the downtown area of Vancouver. So these are all shape files. You can see all the supporting files, the DBF, PRJ, and SHX. So FME has the ability to read zip files as data sets. And when we're working with FME Desktop, you might be familiar if you worked with shapefiles, you only need to specify that .shapefile. FME will automatically load any supporting files. We have to be a bit more careful when we're uploading data to FME Server, because if we just upload that shapefile, we're not going to automatically grab for upload those supporting files. So I'm just going to send this to a compressed folder here. So I get update 001.zip. I can use this in FME Desktop and FME Server. As far as it's concerned, it's a shapefile. So I drag and drop that onto the FME Server web UI. You can also use the upload options here. For Google Chrome, we also have the option to upload a folder here. Not all browsers do support that. Chrome is really handy when we're working with geodatabases, so you can upload the entire geodatabase rather than zipping that file. So pretty soon here, back on the notification tab here, within a minute, we should receive our first notification on shape incoming file. So when that notification does appear, we'll see some information presented to us that's returned by the directory watch publisher protocol. So we'll see on the directory watch publication, we get such information as a publisher path. So that's the direct absolute path on the local machine or network machine where the directory we're watching, the new file path and name. And this dirwatch publisher action lets us know which which parameter has been flagged. So of course we've just selected create. Other ones we can see are modify and delete. So there comes my notification here. You'll notice that we do escape the backslashes here. If you are working with multiple OSs, or if you're watching different types of network directories, you might have to flip the slashes there within your workflow. So it's something to be aware of there, is that we're returning here with double backslash. So that's exercise one, just setting up a very simple directory watch. We'll be building upon this in subsequent exercises to work with and process the data that we upload. As well, we're going to enhance our notification system to also work with data that is emailed to FME Server. So one thing I haven't done, I think I may have completely ignored yesterday, is this handy little hand panel. Just from a little show of hands, again, using the GoToMeeting control panel, how many of you are currently using FME Server's notification service? So if you want to just indicate on that side panel there if you are currently using FME Server's notification service. All right, so there are quite a few hands going up, but notably we do have a lot of new users to the notification service, and that's great. Remember to ask any questions you have or clarifications that can be made. We'll do our best to address them right away, and if we can also, I'll say it as well. Keep Laura busy this morning. All right, so we're going to continue on discussing email notifications. So email is one of our most used notification protocols, both for receiving and for sending. We do have two supported protocols, SMTP and IMAP. SMTP is directly sending or receiving email. We have FME Server, these training machines configured as they have a public IP, so we can send email directly to FME Server, which is, I think, very cool. So while we have IMAP, this indirect process where we can connect to an existing email service like Yahoo, Microsoft Exchange, Google Mail. So in these exercises, we'll be primarily working with the SMTP, but if you also want to configure for IMAP, you have the option to do so. So creating an SMTP publication, that's, as I mentioned, sending an email directly to FME Server. So you'd simply come in here to create a new publication to wait for these incoming messages, and selecting the email SMTP protocol, there's only one parameter, and that's your email username. So in this example here, it's set to road info. We don't actually need to add that at domain.com or what have you into this. With a public DNS, a public IP, this at hostname will actually be set to our IP address. And I believe we do have a file on our desktops to easily identify this for us, so we know where to send email. Alternatively, if you have or if you wish to access an email service, an external email service, we can use the IMAP publication, where you'll see familiar parameters for your host, port, email account, password, security details, and what have you. One important thing to note and I'll mention it again, Gmail or perhaps other services where you are using two-step or two-factor authentication, such as getting the email or the text message with a passcode. Those services are not by default, we'll say, compatible with setting up for an IMAP publication. But these services, such as Gmail, do support application codes. So an application code is something that you can set up specifically for that email service, specifically for a type of application. And you, in place of entering your regular email password, you enter this string, this code that's generated and designed for only, as an example, FME server to use. So what email publications do is they pull your email account if you're using FME Server's IMAP publication, or as soon as an email comes in, kind of sitting passively with an SMTP. So IMAP actively checks. The other type of notification for emails is the subscriptions. And this is where we support sending an email, and this is done through the SMTP protocol. So we do not have email servers installed with FME Server, so you do need to connect to an external service. Again, we do support like all the regular emails, Microsoft Exchange, Yahoo, Google. Internal email services as well are supported. And the same thing applies here if you use a service that has two-factor or two-step authentication. Just be aware that you might need to obtain that app code. While we do specify all these parameters here, email to, your CC, blind copy fields, as well as the from subject and the body or the email template, we can set these up in the email subscription for them to be static, or using transformers, in FME workspaces, we can actually set up our workflow to dynamically populate the values of all these email fields down here. And that's exactly what we'll be doing in upcoming workspaces. Right, so I've started to mention workspaces, and they're going to be a key component to this notification system that we'll be developing. Whereas you can have a simple notification service where we have a publication hitting a topic which invokes a subscription, we can also throw a workspace in the middle and have the workspace built in FME Workbench actually digest the information, that message, process that data, and format it differently, as an example. It is very common for some of these messages to contain spatial data, and what not better way to manipulate spatial data than with FME. So in this example here, this is what you might describe as a full notification system. We have a publication, publisher that's sending a message to a topic. That topic is then directing it to an FME workspace. So this workspace is actually a subscription. It's subscribed to that topic. We process data, and the same workspace actually now acts as a publication. So it pushes out that message to the topic, where we have on the other end maybe an external client service waiting for that message. So the workspace, again, in the middle here can act as both a publisher and a subscriber. You can also work with partial systems, which in my experience I do see more commonly, where we just simply have a external event, a publication triggering a topic, and in response to that external event, we have a workspace running. Or Similarly, we have a workspace running, and upon completion or even during translation, we can notify a topic to call on an external event with that message. So we have, yes, workspaces as a subscriber, and that's what we'll look at first. And then we'll carry on to see how a workspace can also work as a publication. So when a workspace is triggered by a publication, it's receiving a message via that topic that's sitting in the middle, kind of directing the traffic. That workspace can be designed to digest that message, or it can simply just run in response. So to set up an FME workspace, we create, FME workspace as a subscription. We do have that option available as a protocol, the FME workspace protocol. This is the same protocol that's been around for a few years. We've just renamed it from workspace to FME workspace. The FME workspace subscription is particularly useful for migrations. If you're configuring subscriptions for push notification and you've specified that direct URL as your push, if you migrate FME server, the host name is not going to change, whereas the workspace protocol does have all the correct references updated whenever you migrate any FME server solution, or if you back up and restore to a new host name, as an example. So this example image here shows a user creating a new workspace subscription, subscribing to the incoming road info topic. Anytime that topic is triggered, the workspace will run. In the protocol settings, we can select our repository, we can select a workspace, and you'll notice here that there is both a source and a destination file. And for each, we can have, there's these special options here that we can select. So get value from topic message, and also send result data in success topic message. So these parameters, those checkboxes there, will replace either the source parameter or the destination parameter. And once we get working in the exercises, we can investigate what these options are. So there are two ways to set up a workspace to retrieve file name information. First method is using the FME server parameter FME topic message. This is one of those fixed FME server parameters in our FME server parameter under user parameters there. This one down here. And another way to obtain that information is by actually just selecting that get value from topic message. So this is the one we'll be working with in the exercises. It is a new option here in FME Server 2017 that's been exposed in the web UI. It has always been there, but it's been hidden here in this user parameter. So we feel now that using this method here is a lot easier. So what this actually does is it's just passing the file name containing the message. So we'll see how using this option is a way to kind of dynamically create a workflow to process any file that we send in. So let's jump into exercise 2, continuing on with our building updates notification system. So what we will be tackling here is how to set up a workspace to run in response to a notification. So we've set up this notification system where we have a directory watch that's watching a resource folder on FME server, and it's producing a notification every time a data set is placed there. While we haven't put any logic on what to do with that data, we figured that as part of our workflow, every time that a data set is pushed there, it would be helpful if we actually did something with it. So if you haven't done the configurations from exercise 1, then you'll find that the subsequent exercises are not going to work. So the requirement for this building updates notification system set of exercises is we must work through these in sequence. So we'll start with a new workspace here. And we're going to create one of my favorite workspaces here, a creator and a logger. This is one of my favorite workspaces just for testing out if notifications work. So I'm just going to go ahead and publish this right up to FME server, just a creator and a logger. Just leave the default none to none. And then we only need to run it with the job submitter service. We're not doing anything fancy yet. My classic close and open of FME Desktop. So back in the FME Server web UI, let's come on to the subscriptions option here in the notifications. So you can access it via the left-hand menu. Create a new subscription. We'll call this one. This is going to start processing our building updates. Now, of course, I have just created this very simple workspace, but we can come back in and edit this subscription to point to a workspace we'll be creating down the line. So I'll select the FME workspace protocol, where we have all the items come up here. We'll want to make sure we subscribe to that shape incoming file. So anytime file is uploaded, it notifies this topic. And now a subscription will run a FME workspace every time that topic is triggered. And I'll just drill down training and that none to none workspace that I uploaded. For now, I'm not going to worry about continuing on this workflow here. So if I did choose to post to a topic on success or failure, then I can create that full notification system and have my workspace act as both a subscriber and a publisher. This is one thing where it's helpful to label your topics with the direction, such as incoming. For if I were to post to that same incoming file topic on success, that means every time this workspace would run, it would trigger itself again and again and again in this endless loop. And then we'd have to deal with that quickly, or depending on the speed of these notifications, we might just end up crashing our system. So for now, that's all you need to set up, just that creator logger transformer. We'll hit OK. Now we need to look back at this topic monitoring. I'm going to clear my results, so I'll just have a fresh set to ensure that it's still working correctly. Let's upload another file. For the purposes of this exercise, you can upload any file. We don't need to upload a zipped file data set. No processing is happening, and any new file in this directory should trigger that that shape incoming file topic. There's no logic to determine, only trigger if it's a shape file. And then in turn, that topic will trigger the workspace subscription. So again, this will take about up to a minute to run, as the directory watch protocol in FME Server 2017 has a polling approach, as we see with the IMAP publication in FME Server. So while that is waiting to have that poll, I'll continue on with the training content here. One important thing to note, or another important thing to note about the directory watch protocol or any polling type interval publication is if we're uploading a series of files, perhaps if they're not zipped or if we're just uploading a batch, if it spans an interval, we're going to get a delay for the notification. So we might upload 2 files in succession, but if it just so happens to span that 1 minute interval, we're going to get one set of files triggering the topic, and then there'll be another minute in our case here until that second set triggers. This also goes the same with updates and deletes. So you might be, if you have your directory watch to look for changes in a file, say you have you're watching a resource directory where you're actively working with a file, maybe hit save. The poll interval triggers, but you continue working on it and you hit save again maybe, so you've now changed that file size, changed all the metadata twice. You have the chance that you're going to trigger the topic twice, and you might process your data twice. So when you're working with modify, that's one important thing to note is that the concept of the poll interval. So if your data is going to be changing over a longer interval, consider increasing it from maybe not a minute. So we did get that shape incoming file notification. We see that in the topic monitoring. But how can we confirm that anything actually happened? I'm going to use my other window here. We should see that that none to none job has been invoked. And there we have it there, kind of peppered in with all this the schedule here. I'm actually going to go ahead and disable my schedule here so we can, just to make sure things don't get lost here. So that test schedule that was running every 30 seconds, I still have enabled. I'm just going to go ahead and disable that. Okay. So incoming message handling. So the key reason for using FME Workspaces as a subscriber is they can receive the message from the topic and interpret that data. We can use a variety of different transformers to interpret a message. A lot of services, a lot of protocols operate with push and XML type language. So that's really easy to work with JSON and XML and FME. Our notification service, our topics pass information back and forth in JSON. So in this example here, we have an attribute file reader, and we're getting this information directly from the topic. In the earlier section, it was noted that the FME topic message, FME server parameter, contains the source file name. So using the attribute file reader, we can use that parameter as the source file and read that data into an attribute. And then in this case, the data must be JSON format because we're using the JSON flattener to actually start to expose that data for us to work with in the FME workspace. And this is an example here, an incoming message sent via a topic. This is the email publisher that's sending this information. So anything we see here in this key value pair, we can expose in an FME workspace and use in our workflows. And then using the JSON flattener, that idea there is that we're actually now creating attributes of these keys. So then we can actually grab it, get a handle on them in the workspace itself. If emails contain attachments, FME Server does support working with those. So attachments are saved to a directory specified when we create a publication. We'll see that. And we can work with that data, that attachment, which is uploaded usually to a temporary folder in the FME workspace that could be triggered. And exercise 3 does continue on with that idea. So it's going to start to actually process the message sent by the directory watch publication. And we're gonna, the workspaces, we're gonna configure our workspace to interpret that message and to start actually performing an operation on that data, start using that data. This is the next step, right? This is the next step towards achieving this building update notification system where we're gonna actually start pushing to these updates right into a database. So again, this exercise continues where exercise 2 left off. They're in sequence here. So let's create a new workspace. This is going to be a different workspace than that created logger. Of course, that had no capabilities whatsoever. Let's actually make a workspace that can process a message. So the message from the topic is in JSON format. We can use either JSON or text file reader. For this purposes, I'm just going to use our handy text file reader, because when you add a reader, you have to specify a source data set. I'm going to go to my FME data 2017, just select this README text file. It can be any file really, because when this workspace runs, we're going to actually configure it to use the data set from the topic. So come into the parameters before you add the reader to your workspace and make sure that we set this to read the whole file at once. If we don't, then each line of that notification, that JSON message, will be read as a separate feature, and that's definitely not what we want. So once we have that on the canvas there, I know the message is coming in JSON format. Let's add that JSON flattener. And we only have one attribute set as our JSON document. That's a text line data. So the text file reader, when it reads in that text file, so in this case that readme.txt, it stores all that in an attribute called text line data. So that's the feature, that's the data set that we have to work with in our workflow. And let's add a logger to the JSON flattener. There's a shortcut. You can right click and connect loggers, or the hotkeys Control-Shift-L will automatically add them to your input and output port. So this is kind of step one. We need to find out the information that we have to work with. It's kind of like a step in between, step along the way of getting there. So this is chapter 4, exercise 3. I don't need to worry about uploading that text file because we're just going to be overwriting it. And it's also local. Just job submitter service will do for now. And in the web UI, the web interface, let's update that subscription we've created. So I've navigated to subscriptions in the notifications page, process building updates. I'm going to now select the chapter 4 exercise 3 that I just uploaded. And now I'm going to use this checkbox get value from topic message. So this is the same file path that's available through FME topic message. So now when the shape incoming file topic is triggered, that JSON information is going to replace my source file that I had specified when I created my workspace and become the new data set. So I'll select OK at the bottom to update. And again, we are going to we're going to upload a new data set. So navigate to my building updates and my data folder in FME Server Resources. And for the purposes of this exercise, since we're still not doing anything particular with a shapefile, you could upload any data file. I'm just going to zip one up and upload it. Make sure you're uploading a new file, not just replacing. You might not get the delete and then create. You might not get a modify. You might not get anything, because the file size and all those metadata, all that metadata will be the same. So we will receive another topic trigger when that happens. So this is one from earlier. Also, what we'll see happen is a job will run, and because we have those logger transformers connected, we'll be able to see the parameters, those key value pairs of the JSON message created by the directory watch protocol. So there are two ways to observe them. What we're looking for are these options here. This is what we should see in both the topic monitoring and the logging. So you have the option of doing either. You could either monitor the topic to identify this information, or connect the loggers and observe the resultant job log. Why are we doing this? We actually need to know these these keys, so we can start to use them in our workspace. So this is, again, a good reason for why when we're developing this notification system, it is an iterative process, especially if it's your first time. If we come across another directory watch notification system, it's going to have the same parameters here. We could also look this up in documentation if we wish. So there we have, we have that directory watch publisher path, the content, action, and if I come to the jobs page, I have that workspace that I had reconfigured my subscription to run. If I view my log, I'll actually see that same information reported by my logger transformer. So there we have it here. So back into our workspace here, and we want to edit the JSON flattener transformer. Right now, as it stands, we only have the text line data attribute exposed, so we use the JSON flattener to expose more attributes. So I'm going to copy these over from the training manual. We have the DirWatch publisher action. Actually, we only need the DirWatch publisher path, now think about it. We only need to know this, this file path, because we're gonna use the file path to add into a reader, so we can actually start to read that data set that we upload. I'm going to remove my logger transformers, as of no use for them anymore. After the JSON flattener, let's add the feature reader. That's that transformer we can use to read data in mid-translation. So the workspaces are kicked off, but we can use the feature reader now. So we're going to actually read in the shape files, these .zips that we're uploading. And the data set path is presented to us through the JSON message created by the directory watch publisher. And we've exposed that using the JSON flattener, so I can specify it here. I'm also going to select in the output ports, not one per feature type, but I want a single output port just to ensure that is honored. So now that we have this feature reader to read in the shapefile dataset, let's actually write that out to a database. Let's write it out to spatial light. And I'm going to specify that to write to C FME data 2017 output. And I'll just call this will be all my building footprint. So this will be like the collection of all the files. So we don't want to overwrite the database, so make sure that that is unchecked. The idea here is that we're just going to be updating our database constantly. Table definition, we're going to set to manual. When this feature type dialog comes up, we want to make sure that we're going to set a better name for our table. So let's call it building footprints. And just ensure that table handling is only set to create if needed. We don't want to drop and create, because again, we're just inserting new data, updating the database. We'll connect this up to the generic port. So because I've specified an attribute in my feature reader transformer, we only have the data coming out of this generic port. You could think of it as like a generic reader. If we specified a real data set that FME could read in right away, we would see those feature type names displayed below. So I'm going to save this workspace because I don't think I have yet. And I'll put that in my workspaces training folder. And this is chapter 4, exercise 3. And then we'll republish this, republish it to FME server. Because I just saved it there, given a new file name, I lost my republish option. So I'll just have to go through the wizard here again, but I can replace that. Again, leaving it as the job submitter. If you save this as a different file name, you'll have to come back into your process building updates and make sure that your chapter 4, exercise 3 workspace, the correct one is selected. For the spatial light database, we could write out to this local file here, or you can write out to an output folder. I'm going to be working mostly in the web UI, so I'm actually going to change this. We'll write it out to output, and then we have to type in the file name here. So again, let's test our solution here. We'll create another archive of building update data files and place them in this folder to trigger the notification. At this point, you do need to specify a valid shapefile, valid compressed shapefile. If we don't, then we're going to get a failure on the feature reader. We don't have any logic in this workflow to actually enforce the user to upload a valid data set. So if you're ever creating an open-ended workflow like this where someone can just drop anything, whatever they want, you could actually add the test filter transformer in here, where you can actually check the publisher path. Maybe you can see that it contains your .zip extension or .shape or what have you. As well, you can also connect other transformers to your rejected port so that you can handle any failures. That might be helpful for you as well. It is handy in FME Server 2017 that when I'm on my notifications page, but I've navigated elsewhere to a different tab, my topic monitoring continues to run. If you're running topic monitoring on your own machine, on your own network, you'd be aware that this does interact with the default WebSocket port. I believe it's 7078. That's why sometimes it's a better idea to use logger transformers so we can check it in the job log itself. If we have any issues with our WebSockets, we're not going to see any notifications here, even though they are being processed. So it could be a false positive. I can't remember what it would be. I don't know if Laura was listening to me there. she's busy typing away with some questions. Big there. If I have, I was going to say, I think I was just going to say something more on just you have to be very careful when you're creating these workflows to plan for disaster, right? So we checked our job log. Workspace ran. Yes, it did. So in my resources output where I specified to write a file, we should have our Spatialite database. Yes, I do. Let's download it. Let's take a look, see if it's correct. I'm going to open up this in Data Inspector. So I'm going to let it guess. Show in folder. So I open up, if I open this up in FME Data Inspector, Spatial Pipe. There we have BC Place on my canvas there. I don't have any background map set up, it looks like. But now any subsequent data sets that I drop in from this building footprints, I should now start to see them pop up here. So you can test that solution if you like again and again to make sure that it is working properly. Oh, I said BC Place, didn't I? Mm-hmm. That's BC Place. That's Rogers Arena. This is where the Vancouver Canucks didn't play in the Stanley Cup playoffs this year. I just watched the highlights for Pittsburgh Penguins. Sorry if there are any Nashville fans. It looked like a really hard loss. Kind of a cheeky goal. Anyway, continuing on with the training manual. Workspaces as a publisher. So that was working. That workflow we just completed there, exercise 3, that concept is having your workspace as a subscriber. It's waiting for a message from that topic to actually run. So when we're dealing with workspaces as a publisher, we have that workspace sending out a message. Just looking at the time here, we have 10:47. I think this might actually be a great opportunity to end the session for today so we don't have to bridge the theory and practice of workspace publications. So we'll end the session today. I will stop at workspaces as a publisher here. As similar to yesterday, Laura and I will sit here and answer any remaining questions. Was there anything that came up that maybe we could share with everyone else?
Not particularly, actually.
All right, yeah, so yeah, chatter's a little bit low today. That's good, maybe bad. I'm not too sure. Hopefully, if you weren't impressed by my hockey discussion there, you were impressed by the exercises we worked on today. Again, these are operating on just a very basic conceptual level. If you'd like to talk more detail, please ask questions. We're happy to help. We've seen lots of different user workflows, both through contacting support, but also at the recent 2017 FME User Conference. Some people came by to show us or presented their items. Well, actually, I should note, Safe Software has a YouTube channel on the YouTube. And what can I just type in Safe Software here? Yes, the FME channel. So we've actually started to upload all of the user presentations from the FME UC. So you have 11 minutes that you've already dedicated. Actually, you might not be able to watch any of these. They're all pretty long. But have a look, because there were some excellent customer presentations, and they've been recorded, the slides in their presentation, as you can see here. We have quite a few of them up. There are more to process still for audio and video quality. And yeah, so just another resource here to help you. You might find someone's already doing something that you were thinking of doing, or perhaps sharing ideas here. That's what the FME user conference was all about.
In the previous exercise, we were working with the FME workspace as a subscription. So we had the directory watch publication notifying a topic whenever a new file was placed into the building updates resources, and in turn a workspace was invoked. In the next exercise, we will be working with an FME workspace as the publisher itself, hitting a topic where we could have a subsequent subscription. So that would complete these partial systems, and we would have this full system. So the section on workspace publications. So workspaces can be set up to trigger a topic in one of two ways. That's using a transformer, the FME server notifier, or when publishing the workspace, we can actually register with a topic that we've created. So both these ways, we can have the FME workspace created in an FME workbench, hit a topic, and in turn kick off a subscription, anything subscribed to it on that client end. The advantage of using a transformer to do this is we can actually notify topics from FME Desktop, from FME Workbench. If we register with a topic when published, then we're submitting all the configuration to FME Server, and in FME Server is where we would need to ensure that the topic is triggered. So to register a workspace publication, in the FME Server Publish Wizard, for each of the available web services here, data download, job submitter, etc., we can click on the Properties button, and this opens up a separate window. On this window here, we can see under Notify on Job Completion. That's where we can register this workspace to post to a topic either on success or failure. For example, here the data download service. Once this workspace successfully completes its translation, it's going to post data to the topic road info, and then anything subscribed to that will consume the message passed on by the topic. And as mentioned, the FME Server Notifier Transformer. So in this example, the workflow here, we have some data coming in. It goes through this tester transformer. Maybe the tester is doing some data quality. Maybe it's doing some simple analysis to make sure that fields have been populated. Any data coming out of the failed port here is going to enter into the FME Server Notifier Transformer. And the FME Server Notifier Transformer is very simple. The parameters, we just have a topic, so in this case again, road info, and a content message. So you might ask, well, how do I define that content message if I'm registering with a topic when I publish my workspace. And in that case, the content message is actually generated unique to the type of publisher that you're using. So the directory watch publisher versus the FME workspace publisher, they would use different content structure that's actually passed to the topic itself. Using the FME Server notifier transformer, we can actually define that content ourselves, and in this case, using the @value of the attribute road conditions, so that the value of road conditions here will be populated for every feature that enters the notifier transformer. That's dynamically setting this content message. Another advantage you may see here, the FME Server notifier sits kind of in situ with your workflow here. So the workspace publication itself, or sorry, the workspace subscription itself, rather it can only kick off at the end of the translation, a successful or failed translation, whereas the FME Server notifier transformer can operate during a translation. And again, to note, the workspace does not need to be run on FME Server to generate this notification. The notification, of course, happens on FME Server, but we can produce that same notification when run using FME Desktop. And the caveat here, you don't know whether the workspace completed successfully or not. So each option to have a workspace as a publication both has the pros and cons associated with it. So this section just has a little bit more about the outgoing message handling, just describing how we can indeed set that content message. And we can always use the text file writer to set the content message and using the MIME type option here. So the standard for FME server notifications is to use JSON, but we can also easily configure this to use XML. So the client maybe has a requirement for either, and we can ensure that this way it is honored. So I think this is a good time to jump into exercise number 4, continuing work on our building updates notification system. So here we will be looking at the email publisher and email publication. It is another one of our top or most popular notification services to use in FME Server next to the directory watch. So the goal for this exercise, now that we've set up our directory watch, perhaps it's conceivable that not everybody has access to the shared network, or perhaps if you're working remotely, you cannot use a VPN to connect to your network. So we're going to set up an email publication. And with the email publication, we'll be able to send in that same data set to FME Server and have it process accordingly. So the first step here will be to create a topic in FME Server. So I'm going to go to my FME Server web user interface. Just on the home page here, we can select Manage Notifications at the top menu. And we're going to create a new topic, and of course we can do that via the new publication as well. So for creating topics, you have the option to create it in this page here, but we can also create topics right when we're creating a publication or subscription. So let's follow that practice because it's a little less button clicking. So this is going to be my email receiver publication. And we're going to publish to a new topic here. We had shape incoming file. Let's now do, we have a shape incoming email. So I'm going to create that topic and select the protocol. I'm going to choose email SMTP. So FME Server, these training machines running on Amazon EC2, they have a operating email server, sub-etha. For those of you who were using FME Server 2016.1 and older, this is a new set of libraries that we're using. Previously, we used the James email server. So if you did not have a public DNS and public IP for the machine where your FME server is installed to, you'd have to leverage email IMAP and connect to an existing email service such as Gmail, Yahoo. The advantage of this training course and these machines is that they are already configured for us. So as per the training manual, step 1, our email protocol settings or username will simply be FME shape processing. One thing to note here is you do not need to add the @domain in this interface. It's automatically assigned to that public DNS or IP. And for these machines, I'll show you where we can find that information. If you use the IMAP publication, there are some additional parameters that need to be set. They are noted in the training manual. It's the interval, email, it's to fetch, and you have to select a resource folder. This is automatically set for SMTP publications. SMTP publications kind of, you can think of it as passive. They just sit there waiting for emails, whereas an IMAP is more of a polling approach. It's going to go out and check every X minutes. In this case, 1 minute, we're asking you to set that to. But on these training machines, we can simply just use SMTP. So back in my web UI, I'm going to hit OK to create that. So now my email is going to be FME shape processing. And to find that domain, we have actually a handy link on the desktop. Let's move my windows out of the way here. Should be your computer DNS name. So if I'm going to create a new, open a new tab here on Chrome. I think if I drag and drop here, great. So it navigates to this local endpoint, and now this is the public IP for this computer. So I have an email client open up here, Gmail. I'm going to send a new email to FME Server. So I'm going to make sure that my topic that I've just created, the shape incoming email, is correctly invoked. So I'm going to set that up in my topic monitoring. Then I'll come back here, create an email to FME shape processing. And from that link on the desktop, I'll copy that domain, paste that in there. And this is just a test email. I don't need to worry about the subject or body. Send that away, and fairly instantly I should, there it is, receive that notification in FME Server that the publication, the SMTP publication, has worked. So in here in the topic monitoring window, we can see the content created by the email SMTP publisher. See the subject, the sent date, content. If there's any attachments, we'd also see that. So now let's create the workspace that will actually process this message. In FME Workbench here, I'm going to open an existing workspace. If I navigate to my FME Data 2017 Workspaces server authoring, let's open up real-time example 4 begin in FME Workbench. So this should look familiar if you had been working along in the previous exercises. I'm going to open up the JSON flattener here, and we need to add another attribute to expose. So we're going to be sending in attachments, the shapefile data, with the email. We need to expose that attribute so that we can create our workspace to process that attachment. So in the training manual here, we note down in step 3, there are 2 new attributes you can add to be exposed. The reason why we're adding 2 here, we can create one workspace and it can be dynamic. So we can set this up for an IMAP publication. We can also set this up for an SMTP publication. They have different attribute names created by their publishers. So just paste those 2 in. That's making a more robust workspace here. So once you have your attributes to expose, then we can close the JSON flattener, saving that information. So we do need to add in some logic to our workspace. So if we receive either an SMTP attachment, an IMAP attachment, or a directory watch, remember that attribute is set up here in the feature reader. We're referencing that as our dataset path. So let's create a new attribute that's smart, that knows which path is populated. So to do that, we can create a conditional statement in the attribute manager. So adding an attribute manager in between the JSON flattener and the feature reader. In the parameters here, I'm going to create a new attribute called dataset, and then setting the attribute to a conditional value. I do list the conditional value we need here. I will essentially be setting if directory watch publisher path has a value, then that means it came in from directory watch. Let's set dataset to that value. That's blank. Maybe it came in through SMTP. If it did, let's set it through that, and the statement to catch the IMAP publisher. Now in this case, we're just not going to do anything if this workspace is triggered and it doesn't have any of these values published in an incoming message. You could further enhance this workspace to be compatible and to handle that sort of error. So I'll just quickly add in these 3 rules here. So if my directory watch publisher path has a value, then let's set the dataset attribute that we're creating to dir watch publisher path. If not, let's do a test on our SMTP publication attachment and set that as appropriate. And if it doesn't have that, maybe this workspace kicked off through an IMAP publication. So if that has a value, let's make sure that is set appropriately. And again, if it doesn't have any 3 of those values, we're just going to take no action. Workspace will fail, but for the purposes of this training exercise, we are not concerned with that. Last thing I have to do is just edit my feature reader to point at that dataset attribute instead of dir watch publisher path. So I still have my default Spatialite database in there. I can edit the publish parameter so that it's always going to choose our Spatialite database in the output folder. So in step 6, we list the full value you need, and that's using FME shared resource data, that macro that's populated at runtime for an FME server workspace. So I'm just going to copy that in directly from the training manual and paste that in as my destination. So now when I publish my workspace, I don't have to worry about changing anything in the web UI. So I should save this. Go into my FME data 2017 workspaces. I have a training folder here. In that training folder, call this chapter 4, exercise 4. So let's publish this to FME Server by using the publish button there. Launches the wizard. I have my existing FME Server connection. Publish it into my training repository. I don't need to upload that data text file because it's going to be overwritten. But on the next screen here, in order to now have my FME workspace act as this publisher, select the notification service. And you'll notice it's in red. That means that we have to edit the web service properties. Open up that dialog. So see, we have to select our topic. So let's select that shape incoming email topic. And that SMTP publisher that we set up in FME Server sends a message that it creates a JSON message to a topic. That topic is going to send it to where? To this workspace. What is going to digest it? That text file reader. So make sure you select that parameter to get topic message. And once I make that change, I can publish that to FME Server. And the training manual does note if you have completed exercise 3, you may also consider updating your Directory Watch subscription to point at this workspace. Because with this workspace, we have an FME workbench. It's now good for both Directory Watch and email publications. So let's test to make sure that this workspace was successful. In the FME Server web user interface, you'll see here that now I already have that workspace subscription created from that publish wizard. So I can see the user that logged in FME Workbench, see the repository where that workspace is and that workspace name. So this is automatically created when you register with the notification service. I'll continue to monitor that shape incoming email. I'm just going to clear the message here. Let's send a new email. To FME shape processing, make sure I select the right one. And so this one will be dataset attached. So I'm just going to verify that my email publication works. It's going to take this email, pass the information to my workspace. My workspace is then going to process. So I'm going to do zip up the shape file for update 3. And I'll just add that to my message. Fire that off to FME Server. Should receive a notification that an email has been sent. And that notification has come in. So there we see now our data set. Our attachment is email publisher attachment. It's the first element of that list. So if you're using an email that maybe you had a signature that has your LinkedIn icons, they would also come in as attachments perhaps, and you would have to filter those out, and you'd probably be wanting to process the entire list of attachments rather than we're just selecting this first element because this exercise has been, of course, fabricated to work that way. So it does have update 3 zip. We should have seen now in our completed jobs a workspace that kicked off. There we go. Chapter 4, exercise 4, kicked off a couple minutes ago. And in our resources folder, we should see that output and our Spatialite database building footprints was written as expected. So that completes the exercise 4. Using FME Workbench, we updated the workspace from our building updates notification system to work not only with the directory watch but also with email publications. And using FME Server, we set up FME Workspace to act as a publication as well. Sorry, that is, we worked with FME Server to create the email publication, and in the subsequent exercise we'll see how to have an FME Workspace act as the publisher.
To make sure your directory watch subscription is still processing by dropping a file directly into your building updates folder here. And then you'll notice that update 4 isn't placed in here, rather it should go into this system temp folder, email attachments. This is actually where I have my data coming in. You'll notice it has the date and timestamp of the email. Also in the folder name here is who the email was addressed to, so this FME shape processing, and the subject. And then if you actually come in here, you'll see all the attachments. And all these attachments can be set to be cleaned up. I clicked on the system cleanup page under the admin menu, and we see that here I have delete email attachments. These are all enabled by default, and after 86,000 seconds, or 1 day, that is when my email attachments will be cleaned out. So note that's the maximum age of the file and folder itself, not a calendar day per se. Note that you can also set up filter types here on all these attachments. So maybe you only want to clean up your compressed attachments, or you want to save the compressed attachments. There's a lot of configuration you can do here on system cleanup. This is normally an admin task, and in the admin course that's designed, that's where the system cleanup page is covered in a little bit more detail. So back to the training manual here, moving on to the next section, discussing using a workspace both as a subscription and a publication. So currently we've just been working with this partial system where we have our directory watch or our email publication. When there's an email or new file, message is sent to a topic where we have a workspace subscribed to. We created that workspace subscription either in the web UI or in the FME Server Publish Wizard, but now we can develop our notification system to be this full system, and we can have this workspace. So we'll configure this workspace here to actually send out a notification to a topic. So this workspace will be a publisher, and then we'll kick off another subscription. So one example noted here is you might have a publication, maybe a WebSockets watching a feed, maybe it's a GRSS feed or something like that, waiting to see when there's new lightning strikes. A lightning strike happens, it kicks off a workspace, maybe it processes data about the time, the location, and then using the workspace as a publisher, we can kick off a topic, maybe send out an alert, an email for people in the area to maybe watch out that there's lightning activity. And again, noted here in the training manual is the issue you will encounter if you accidentally subscribe to topic 1 but also publish to topic 1, you'll get in a loop. So it's definitely something to be aware of, and a great reason for naming your topics to the direction of the notification workflow. So let's take this exercise 4 workspace and let's enhance it to also act as a publication itself. So in this exercise, the idea here is that we're getting building updates via email or directly deposited to folders, but maybe we want to notify someone, maybe someone who's responsible for actually maintaining this building footprint database. So every time that there is an update, we can send an email notification to them to let them know, hey, there's been an update, and they can come in and maybe QA it before actually pushing it over to production. So this exercise continues where exercise 4, the one we just completed, and 3, 2, and 1, they're all required in sequence to have the proper plumbing in order. This workspace also requires access to an external email server, so Gmail, Outlook, or Yahoo. If you do not have access to an email server, or if you're using two-step authentication and you don't want to create this app code, feel free to just watch along here. Otherwise, you will not be able to send out emails to yourself. So I'm going to first go to the FME Server web UI. I'll manage notifications. There are these handy buttons up here, which I do never use. Creating a new subscription here. So we have an email publication. Let's create an email subscription. You'll notice that we do have a few email subscriptions created by default, notably data download, job submitter, and migration. These email subscriptions are subscribed to topics that ship by default here, these job submitter, failure success, all these 6 topics here. And if you wanted to, you could come into each of these email subscriptions and configure them for your external email server. And then automatically by default, data download, job submitter will send out emails if you configure either failure or success. And the migration, so this is for backups and restore here, you can also get emails sent out to your system admins. So they are there partially configured for you to use. But for our purposes, we're going to create a new subscription here. So again, if you don't have access to an external email server, maybe just watch along here. So send building update email, that's the purpose of the subscription. And this is an email protocol. Notice we don't have the option for SMTP or IMAP. It's only SMTP connecting to an external email server. There are some lightweight email servers available for you to install. You could consider doing that. So we don't want to subscribe to an existing topic because those are all topics related to our existing publishers. Let's not get into this looping situation. So I'm going to create a new one called building update email. I could even call this outgoing. So I'm going to use my Gmail account here, that FME shape processing that I set up. So listed in the training manual, smtp.gmail.com and port 465. These are, of course, things you can Google fairly easily. enter in my credentials here. And notice that we only have a few required fields here that are highlighted in bold, so got to make sure this is coming from who's going to be on the firm. I'll put my own email here. The one cool thing I would notice, I don't know if this works for other mail clients, but for Gmail in particular, if I put a plus here, I can say training course. So this obviously isn't my email, but if I get now an email from this address, I see plus training course, then I kind of know where to backtrack and disable things. The email subject, this will be the database, the building update, building footprints, database is updated. In an email subscription and publication, these are things we can, or sorry, in an email subscription only, all these email fields are items we can dynamically set, and that's what we'll do in our workspace. So I'll give an example here. So I'll just put this as the default text. So if we do not see this change, then we know that something's going on. We can set all this dynamically, email to CC, BCC. When I click OK here, it's going to do a quick verification to make sure that I entered in my correct credentials. So I do have this valid configuration item here. That's great. So now I can actually go back into my workspace here, and now let's add that logic to send out an email. So on the feature reader transformer, out of the generic port, we're going to get every feature that's coming in. So this could be one or many. However, out of this initiator port, we only ever get one feature when we have a grouping of features come in, or sorry, read in via the feature reader. So this is an excellent way to kick off a notification, so we ensure that only one notification is sent. If you don't have the feature reader transformer, you could use something like a sampler and then come in here and just sample only the first one feature, and that will limit the amount of notifications you send out. Otherwise, you're going to send one out for every feature. So I'm going to leverage a transformer from the FME Hub, the FME Server email generator. So this transformer, custom transformer, available up on hub.safe.com, just populates and creates the JSON structure that a email subscription can read. So this is where we can see an example of overriding those email parameters in the subscription. So we do have some required fields. So I'm going to actually send it back to myself, so I don't have to log into my personal account. Subject, so database updated. And the idea here is now when I actually send out that email, I already defined these items in the subscription itself, but using this server email generator, this should be overridden. So check it out. We also have the option to add attachments here in an email, which is really cool. One thing to note here, if you're adding attachments with the server email generator, they do need to be accessible by FME servers, core, and engines. So if you specify a local path, it must be local to those two services, or any UNC path must ensure that proper permissions have been set. So connected out to this is my FME server notifier that I'll place. And then gotta get in the habit of using this parameter editor because it is so much easier. Connecting to FME server, a connection I've set up, and this is going to send a message to that building update email outgoing, and the content. So this transformer here creates a text line data parameter, and that's what we're going to reference in FME server notifier. So again, you can dynamically set the content, and we're using FME server email generator to do so. We would also be able to add any additional information here in the content by using FME feature attributes if we wanted to. So we can say like data is available at, and then I'll put in my email publisher path there. So I'm going to just leave the exercise name the same as exercise 4, even though this is exercise 5. Why am I doing that? So I don't have to go into my workspace subscriptions for email and for directory watch and update to point at a new workspace. If I leave the workspace name the same, then I don't have to worry about doing that. So that's it. That's what I'll do here. I'll just replace what I have up there. Just make sure that my notification source, everything looks good still. So now when I send an email, I'll get a new zip file here that I should receive an email back letting me know that my database has been updated, because now I've configured my FME workspace to not only act as a subscription, but actually act as a publisher by leveraging the FME Server notifier transformer. So this will be update 5 I'm going to pass in. And I got to make sure I send it directly to my FME server instance, FME shape processing at that EC2 string. Another update is attached. So we should get a notification right away. Oh, maybe not, because I didn't watch my topic monitoring wasn't on. That's okay, let's check the jobs. So I had that chapter 4 exercise 4 run here a few seconds ago. And if I come back in here, I've received that email. So I had that feature come out into the FME server generator. Setting those fields, you can see that my subject and content have correctly been overridden by the JSON string created in this transformer, passed through as text line data into the notifier as the content. And there we can see we have that attribute populated. So if I was local to FME server, I can copy this path. And if I paste this into Windows Explorer, I should see that update file that I had. So I've got 951, and there's update 5 available there if I wanted to use it there. So how many people were able to maybe use their own email account in conjunction with the one we have on FME server training to actually receive an email themselves? So just use the hands up option in the go-to webinar control panel there. Just give us an indication of how many people were able to successfully complete that along with us. All right, great. And for those of you who watched, I hope you are going to walk away with some great ideas of how to set up an email subscription service for yourself. So this is just one way we can have an email sent out. I believe new in either 2016.0 or .1, we have an emailer transformer. So you can actually use this emailer transformer and kind of take out FME server from the equation in this email subscription. We wouldn't have to create an email subscription at all. You could come in here and select an email service. So it looks like we only have a template for Gmail and then generic SMTP. You can set up all the same parameters and add attachments as you see fit. And then you would again just connect this up, in this case, to that initiator port, and then the email would be sent when we run the workspace, either on desktop or server. It's another option there to send out notifications. The advantage to setting up a workspace an email subscription. So that email subscription can be used in multiple workspaces. If we set up an email or a transformer and any connection information changes or we want to change the message, then we have to come into the workspace. Of course, using an email or transformer, we get to set a message for each email or transformer instance we have, whereas a email subscription, we're limited to the template that we set up. There are a whole bunch of keywords that you can set up in an email subscription as well. If I go to my notifications, if I click on that email subscription that I created, let's see here. If I click on documentation, while I'm in that subscriptions area, it should bring you to this subscriptions documentation where you can look at the email protocol. And for the email subscriber, we can see this template language. So we can actually, there's some examples here of using keywords that FME Server will dynamically set. So we can use, for example, if you have a data download service, you can use keywords for data download. They're all listed here on this table. So these are all parameters you can specify in your email subscription body. They'll automatically get populated at runtime. And just a simple note here, some of them are only available for data download and not job submitter. So that concludes the notification section of the real time. So that's again dealing with these discrete messages that come through at a rate of maybe up to 1 per second. If we're working with messages that process more than 1 per second and we need that data processed fast, we would probably consider using message streams, that architecture in FME Server or FME. Message streaming can handle the continuous wave of notifications or events or alerts for processing. When we're using the notification service, our primary data processing is, of course, in the FME workspace. Every time we start an FME workspace, there's always that overhead of initiating an engine. While it may measure in 0.1 to 0.5 seconds to actually initiate an engine, if you're working in high capacity message streaming, that obviously is going to become an issue and you might get backlog of data. We are finished with the notification services as they are in FME Server for the training manual. We'll now be looking at message streaming, which is that handling of continuous messages, the more real time of processing. So then we are looking at these more than 1 messages per second. So as I mentioned, when we are working with these kind of discrete messages and we set up our email subscriber, workspace subscriber, if the interval of the average message is less than the time taken for the notification to start and run a workspace, then we're gonna see a backlog. We're gonna see our system struggle. So about the 1 message per second is a good cutoff for this. High capacity message streaming on FME Desktop and Server can handle, of course, thousands, hundreds of messages per second, so you don't necessarily need to worry about limitations there. They often end up being on hard disk or memory is your limiting factor there. So similar to notifications, the message streams can be both into and out of FME. So in this little diagram here, we have potential for a sending application for FME Server to receive, and then FME Server itself processing a message or creating a message and sending it out to a receiving application. So whereas in the notification service, we were using publications, topics, and subscriptions to handle these events and to send out events, in message streaming, we actually have transformers that will connect to various protocols for us. So the receiver transformer acts as the subscriber, listening to a message stream. Once it has data, it can send it downstream into your workspace to be processed. And then perhaps you have sitting on the other side this the sender transformer, which acts as your publisher, creating that message and sending it to an open stream. So some of the protocols we natively support in FME include JMS, WebSockets, TCP, and then Amazon's SQS and Kinesis services. We also do support the Twitter API via the Tweet Streamer and Tweeter transformers. Now, if you don't see your favorite protocol listed here, you can always use our Python creator and Python caller transformers. These transformers allow you to just grab snippets of Python code and paste them directly in. Undoubtedly, there's a vast amount of Python libraries out there that you can use and use within FME. So one thing to note here, receiver transformers and sender transformers, they must have a continuous open connection. So if you have any of these receiver transformers, save for perhaps the Python creator, unless configured appropriately with your code, these receiver transformers actually maintain the workspace in the running state. So if we create a workspace with a receiver, WebSocket receiver, and we start that workspace will continuously be running, waiting for messages to arrive. In the case of FME Workbench, you can always just open a separate FME session. However, in FME Server, each workspace that has one of these receiver transformers will utilize an FME engine. So if you do want to handle multiple message streams, you will have, or if they're in different workspaces, you will have to have a dedicated FME engine for this purpose. Sender transformers operate somewhat similar, in that they are continuously open as long as there is a flow of data. So if you process 1 million features from maybe a point cloud and you're sending them out through a WebSocket stream, maybe just sending out the location, as soon as the features are processed, then the sender will close its stream. However, if you have a receiver and sender in sequence, the workspace won't shut down, nor will that sending or this sending stream. So the message streaming architecture, again, a diagram fairly similar to the notification service. They have our client here sending a message stream. We have an FME engine processing the messages using one of the various receivers or Python creator. The idea here is then you can take that message, process it, filter it with whatever spatial data or non-spatial translation you'd like. And in the same architecture, we can have a sender or Python caller in the same workspace operating on the same engine, connecting to an outgoing message stream. The idea with the database here is that maybe we have a database component connected for logging purposes, maybe keeping a historical record. In the case of the lightning strikes, for example, if we're watching a message stream, waiting for lightning strikes, they get processed by the FME engine here. Maybe you can have a database connected so that you have an archival history for analysis at a later date of all your lightning strikes. Yes, I believe that's just a similar example that the training manual goes over through here. So the final exercise of the real-time with FME Server we're going to create a real-time message stream processing workspace. For the purposes of this training exercise, we will be creating our own stream. We won't be connecting to a live external one, but we're going to generate a workspace setup for you that's going to mimic maybe a emergency service that's sending out notifications of incidents. So we'll set up that stream and see how we can process the messages. We'll create a workspace that will actually do just that, using a little bit of spatial filtering and reporting. You'll also see this logger subscription surface that I had mentioned earlier, which is again an option that you can use if, for example, topic monitoring the WebSockets are not operating. All right, so for this exercise here, everyone will be able to complete this on their own training machines. So I'm going to start off with a template that we've provided. In my FME workbench, I'm navigating to see FME data 2017, workspaces, server authoring, and then we have data stream, exercise 1, begin. So this is our mock real-time message stream. What we have here is a creator just sending in a null feature where we have a random number generator here. It creates a random amount of features between 500 and 1,000, and it's cloning these features out, creating a random location. We're also assigning a severity, because this is the idea here is we're mimicking a emergency stream, so we set a severity for the event, and we're randomizing the interval in which these features are passed through. So this workflow does have a, I guess you could say, countable stream of features coming through. Then we create a message using the JSON templater so that it can be sent out via one of these message streaming transformers. In our case, we'll be working with WebSockets. So the first thing we'll do is actually add that WebSocket center. And connect the stream up here. So our parameters here are listed in step 2 of the training manual. We can copy them over really easily. We have to create or establish this connection using this preamble. Note that we can connect to multiple streams with a single transformer, and that is documented in the FME Desktop documentation for the, for in this case, the WebSocket sender. So we have this connection preamble here. I'm going to paste in to right directly into the transformer. So we're going to create a stream called emergency events. So sender transformers are sending it to a stream. We have to create that stream. And data to transmit, we're going to send this will be dynamic. We're going to get the value of this event message attribute here. And then we can turn the SSL verification off as we're just connecting to localhost, and we have not set up our WebSockets for WSS. So, excuse me, so this workspace here is going to generate our stream of data. Now we actually need to create a workspace to process that data. So I'm going to save this workspace. Which for is exercise 6, and this is my create stream workspace. So I'm going to publish this up to FME Server right now. Just in that training repository that I've been working out of. And we just need to register with this job submitter. That's okay. There's no data sets, no parameters we have to work with. So now that I've published that workspace that will act as my stream creator, let's create a workspace to actually process the stream. So I'm going to start with a blank workspace here. I'm going to have a WebSocket receiver. And notice that it's not actually a starting transformer itself, so I just need to have a null feature to kick off this workspace so that the stream will open properly, or sorry, connect properly. And again, in the training manual, step 3, we have this connection preamble, which matches here for the sender. So I'm going to set this in my WebSocket receiver transformer. Again, we will disable the SSL verification, and I'm going to rename my output attribute to something I can understand a little better, incoming message. In order to determine what's actually coming out of here, let's add a logger transformer so that I could view a log file to see all this, all the activity. Save this one here. So this is my process stream workspace. Right now, we're just going to be testing out. That's why we don't have any other logic in here. Publish this one up to FME Server. Again, just register a job submitter. I don't have to worry about any parameters. And then I'll come in here into the web UI. And I'm going to start both of these workspaces one after another here. So I have my create stream workspace, which I'll start running. And you'll notice here it's just going to sit here running continuously. That's because I have that WebSocket sender transformer, and I'm generating somewhere on the order of 500 to 1,000 features, which isn't very many, of course, but I am slowing down the feature creation. So this workspace will run for a few minutes. While that's going, I'm actually going to go back into my run workspace, and let's start the process stream workspace. So now this process stream workspace has that WebSocket receiver. It's going to connect to that WebSockets channel that I just created. And as long as there's features incoming, this one will keep on running, keep on running. So if I look here in jobs running, now I have 2 FME engines waiting for data or processing workspace. Normally, we wouldn't have to create our own stream. We'd be connecting to an existing stream. So whereas here I am utilizing 2 FME engines and regular message streaming workflows, you would only be running 1. So they've run for a little bit now. I should have had a whole bunch of features created, and I should have processed at least a few of them. So I'm just going to cancel these jobs at the moment. That'll give me a chance to view the log file for the process stream workspace, and then I can add some logic to process the data. So the logger transformer, every time a feature came through, we see that it logs the incoming message attribute. And then in that JSON templater is where I was creating this JSON data, mimicking an emergency stream. So we have an event ID, we have a location, coordinates, and then we give it a severity and an integer type, which I suppose could be matched with like a lookup table. And I see one for each event that occurred there. So with our incoming messages, we want to process them. So let's go back into our process stream workspace. And we're receiving this, the WebSocket receiver is receiving JSON message. So what better than to use the JSON flattener transformer? I don't need the logger anymore. I'm going to get rid of that. So if I add a JSON templater, oh, sorry, JSON flattener. Then I can specify, look at the incoming message attribute, and now I can expose these attributes so I can use them in my FME workspace. Of course, the attributes are already there, but we need them exposed. So we have them listed here in step 7, if you're following along. So we can just copy and paste them right over to the attributes to expose. So event ID, our location, has both an X and a Y coordinate, and we want to have those separated out. That's why we have that dot notation. So we want to actually create a point. We're gonna take this alert data, this emergency stream, and we'll create spatial data from it and write it out to a database. So I have my 5 attributes I'm exposing there. And then we can actually create a point using the vertex creator, formerly known as 2D or 3D creator. So we want to add a point, X value for each feature coming through. We're going to get an incoming message. So we want each feature to have its own point, X core, Y core. And now we want to write this out. Let's choose the GeoDatabase API, the Esri GeoDatabase file GeoDatabase API writer. Oh, sorry, reader. Getting ahead of myself here. What we'll be doing here is filtering upon geographic area. That's the idea. So file GeoDB API reader. We're going to read in some transit locations, and then the idea here is someone could subscribe to a transit alert system, and if there's some incident near a transit station, maybe to reroute as appropriate. So we'll navigate to an existing file GeoDatabase folder-based data set, see FME data 2017 data community mapping, and then we have a community map GeoDatabase. I'll leave it as individual feature type here, and when we're prompted, we only want to select the transit stations table. As you can see, there's a variety of data here provided by the City of Vancouver. So I'll bring in my transit stations. And then let's filter these emergencies based on this area. So the transit stations are just point locations, so I can use the buffer to expand that area. Training manual suggests 200 meters, but I'm going to actually use 500 so we get more hits. And then we need now to do this spatial kind of overlap. Let's use the point on area overlayer. Because I have my transit stations here. They're now points buffered, becomes polygon, so that drags to the area point, our area input port, and then our point data from our stream. If you are familiar with the term blocker transformer, the point on area overlayer is one of them. Group-based transformers are often blocking transformers. So we actually want to read in the areas first. If we don't, we're going to be reading in all the points, and of course the point data stream isn't closing, but the areas generated by the buffer, these transit stations, that's a static data set, so we can read all that in first. Setting that areas first here in the point on area overlayer removes the blocking nature of this transformer. We also need to ensure that these transit station features arrive first. So on the creator here, there's this option, this parameter to set create at end. Let's set that to yes. So now the creator will be the last thing that runs in this workspace after all the reading. So we have now on this transformer, we have a count attribute called overlaps. So every time an event is overlaps with the transit station area, that's what we want to send out here, so, or process. So I'm just going to add my tester transformer here. You can also choose test filter. And the clause here will be if the overlaps is greater than 0. We can throw out all the other features because we're not interested in them. And I'll connect up my loggers here. And then I'm going to resave this workspace as my process stream and publish that, replacing what I had there on FME server. So at this point, you could check this workspace to make sure that we're filtering as appropriately, but I'm going to be cautiously optimistic that I've set it up correctly. So I'm going to just continue on with the exercise here, where we'll actually be adding a writer. So we can use a spatial light database. This is, again, just kind of showing you how we can use that message streaming architecture, that full diagram here. We're now going to add in a database to log out for historical record all the events. Because we're filtering out, but we might as well save all the events. So we might want to process them later. So spatial light database, we're going to create a new one called event messages. Leave this table definition as automatic, so we don't need to worry about setting up the schema. And the parameters here, under advanced, we normally commit features and batch transactions of 1,000. However, we're going to be getting these messages in one at a time, so I can set this to 1. So I can ensure that every time a message comes in, we insert a record into that database. So I'll call this events instead of table 1. And connect this up before I filter out. And you can see now we have, because I'm automatic, we're pulling in all the same attributes from point on area overlayer. That's something we can come in here, change to manual, and remove any unwanted features we want. So just an optional step there. So I'm going to save this workspace again. And we can tie in this message streaming workspace into the notification services of FME Server using that FME Server notifier. So I'll just use the logger subscription here. Again, this is something that you can do. Now we don't really have the availability to leverage WebSockets and topic monitoring because we're not really working with a notification service. We're working with this message streaming architecture. However, we can still use this logger protocol, which is just kind of internal for FME, to ensure that indeed we are writing out appropriately. So I'm going to create a new subscription here called emergency transit messages of type logger. And I'm going to create a new topic here. I'll just call this emergency transit messages as well. Set the logging level to high if you're following along, so we just make sure that all the data is logged appropriately. So now that we've created a subscription and a topic, this is something that we can monitor in our web UI using WebSockets, or it will create a log file which we can access through the resources page of FME Server. So every time a message comes through and is in that area, let's connect up this FME Server notifier. So just place that in between the tester loggers there, and then I want to connect to my server, hit that topic I just created, and then the message content for this purpose can be anything we want. So we have a hit. So every time we get a successful hit here, that means that our event is within this buffered area. We should get a post to the topic monitoring. So I'll just republish that workspace there. Right, so I'm using now that I'm using a connection in FME Server, that's a more major change in my workspace. So FME recognizes that, and I'm forced to go through this wizard so I can correctly upload this connection here. So if I come back to my web UI, first I'll start my create stream. And while that's going, give it a couple seconds to kick off. I'll start my next one here, process stream. So what will happen when I start this is we'll be filtering based on the transit station locations, and for every event within a certain radius of 500 meters, as I specified, it'll be written to a spatial database. So while those two are running, we can verify by looking at jobs running. Got one engine dedicated to each workspace right now. If I come in here to notifications and observe topic monitoring, I'll wait till I get a few notifications here. So we are getting locations now being written out to that database. Every time we see a notification here, will be a new commit on that spatialite database. And I can open up a new window here and check that I guess I'm writing this locally. I can check that my spatialite database is being updated. So it was updated there at 10:41. That should, correspond shortly after that event occurred. And then as soon as we get another event happening here, we should see that spatialite database updated, that event messages. So again, this exercise just kind of works through a fabricated message stream. Just to reiterate, normally we would not have to create our own message stream. We would rather be connecting to an existing one. Then that would allow us to free up an FME engine in our workflow. Of course, when we're creating a stream, we have a dedicated FME engine working to process that. But similarly, we do have a dedicated engine when we are processing data from that message stream. So when you have message stream architecture implemented in your FME server workflows, you have to be aware that we do require an FME engine dedicated for that purpose. Dedicated engines can be configured using job queues or job routing in FME server. So that is something we support, specifying an engine to only run certain workspaces or workspaces that are in a certain repository. I guess I'll just emphasize that we have received multiple messages here, and that database is being continuously updated here. So if I open this up in FME Data Inspector, then we should see a whole bunch of, quite a few points from all these events. Remember that we're writing out the data for every point and then only reporting in the web UI when it is in that particular area. So that concludes exercise 6 as well, puts the icing on top of real time with FME Server. So the majority of the focus was on the notification service, which is more common. Two of the more common or most common protocols we see people interacting with are directory watch and email. And then it's great to have this example, this exercise, working with message streams so we can kind of learn the architecture on how the engines are dedicated, for example. At the end of the chapter, again, we have troubleshooting for admins or for the author. I threw in this note here about Google two-step verification and the app code. We also have some general troubleshooting here for FME Server. I guess, yeah, in general, we do have on our Knowledge Center at knowledge.safe.com, we do have an FME Server troubleshooting guide, which is very good to point out here. So FME Server troubleshooting guide. We do have a whole bunch of articles. This is kind of like a central location where you can find all our articles for common issues encountered with FME Server. So whether it be issues with the installer, with logging in, we can see running jobs, publishing, problems there. We do have specific sections for working with email or notifications, upgrading, securing. So this is a handy resource here. If you run into any issues with FME Server, come to this page here. You can just query, do a search for some key terms and see if we already have an answer to the issue you've encountered. If not, you always have the option here during our core business hours to chat with one of our tech experts live using live chat. So actually, I'll chat out that troubleshooting guide link in case anyone wants to take a browse. And so in review here for this whole entire module that we covered partially today and yesterday, we have real-time systems are these message-driven workflows and where we're processing these small amounts of information. So we're not passing through megabytes of data. This is generally a few lines of text. Geometry could be passed through, well-known text or XML. A notification service handles this individual message or discrete messages on the order of 1 message per second or slower. We have the concept of publications in FME Server that listen for or wait for and respond to notifications from clients such as other web services. Those are pushed to topics where they can then be passed on to subscriptions. And in FME Server, that's where we're pushing out that notification. We have a whole bunch of protocols. As I mentioned, we worked with the two most popular, Directory Watch and email. If you have been working with Directory Watch in 2016.1 or older, keep in mind that Directory Watch has been rewritten for 2017 and is now a polling interval similar to the IMAP publication. Previously in 2016.1, it was that passive, where more similar to the SMTP publication, where as soon as a file is dropped in, we process that message. But now it's the 1-minute interval. And then we looked at the message streams, setting up a workspace that will run continuously. If I come back in here to my web UI, I'll find that, yeah, I still have these 2 workspaces running here. So again, we have a couple blog articles here, use case for creating reports in response to earthquakes, and also a user who was streaming via JMS at 125,000 messages per hour. So it's 10:48. Again, I think we'll end early today. We'll tackle tomorrow. FME Server Projects is the topic. FME Server Projects are a new feature for FME Server 2017. It addresses one of the highest voted for ideas in the Knowledge Center, and it allows you to easily and quickly migrate a subset of your FME server, just one particular solution rather than doing a full backup and restore. FME Server Projects really help out users who have development, test, and production installations of FME Server, which is new for FME Server 2017. On the main page here, you might notice that there has been this box here for recent projects. As well, on the left-hand side menu, we have projects listed here where we will get into with an exercise today and a little bit of description here through the training manual. Projects are designed to encapsulate an FME server solution. And what is an FME server solution? That could be a collection of workspaces, notifications, even resources, database and web connections. The notification service we built yesterday or the data download system, you can think of each of those as a FME server solution. And with a project, we would have the ability to wrap and package that all up, so we would be able to share it with others, not only within our organization with other FME server installations, but also with the greater FME community. I guess just a little plug for FME Hub. We are looking to support projects in FME Hub in the upcoming months because the FME community is amazing and people have great ideas, and I think that the ability to share with these FME server solutions in this project is going to be great. Part of the advantage of FME server projects is you don't have to be an administrator to share these. You can actually be in that authoring role of FME server and share these little packages of FME server with each other. So as noted here, project components can incorporate most components. Also here we have users, so we can actually transfer users in an FME server project. This is very helpful for our data download system. Say we had created a specific user to run all these workspaces that owns these workspaces. Having that ability keeps it compartmentalized a little bit there. So you can think of projects not only as migrating between your development, your test, your production installations of FME server, not only through sharing, of course, but also just as a backup tool. You can take a snapshot of a subset of FME server, your FME server solution, and you can keep them for archival purposes or allowing you to kind of save that copy and then perform some modifications. And then if you need to roll back or revert, you have that file available for you. So creating a project, we've tried to make this as easy as we can. You simply just come in here to the projects page in FME Server, hit new. You can give your project a name, description. Then we have a list here of all the current project contents. And also on the right here, you have where you can select your items to add. So we have a drop-down menu here where you can select all the different types of FME server items. And when you're in any category there, then you can see the individual items. And if you need to, you can view details, so you can see who owns it, what the protocol is in the instance of this publisher here, and then add it into your project. We're really excited to see how everyone interacts with the FME server projects, how they use it, what they find is great, and also what you find is not working or could be better. So if you see any missing items or you think that you need to have a better layout, pop over to the Knowledge Center, knowledge.safe.com, head to the ideas section, and please share your comments with us there. So right, we have the add item category. Select your item. Then we can see, in this case here, Mark had just added these 4 items here. That's why they highlight in green. And then we have a list of projects here, currently listed from last updated. And notably, you can have projects that are a part of projects, so you can have a sort of nesting within there. All the import-export is done on this main project page as well. If you've performed backups of FME Server, you might be familiar with the .fs config, which is essentially a fancy zip file that has all your resources in an XML file, linking everything together. Projects utilize the .fs project, so very similar file structure, because essentially we are creating a backup, much like in the backup and restore page of FME Server. However, projects are just this little capsule. Projects also benefit from sharing, so we have the same options here to share projects and the items within. However, if you do share components of a project and you're sharing with another user who might be a part of a separate role, while they will be able to see your project, they may not be able to interact with every item depending on how the security settings have been set up for that user role. So this page here just describes exporting a project. You can see we have that .fs project extension here. We can save this just like FME Server backups, either to a file, local, or you can save it to the FME Server resources. So keeping that backup of FME Server projects actually just within FME Server itself, which is useful for that snapshot idea. When you remove a project, you can think of it in 2 ways here. We have 2 options, that is. If you simply remove a project, it's kind of like just deleting a file off your file system, like on Mac OS or Windows. The file actually still resides on your disk. All you've done is delete the tree or the reference to that file. So if we remove a project, we're not by default going to remove the items contained within a project. We're just removing that container that we created. However, there is an option here that we do provide to also remove the contents, and be aware that of course if you select this, you could be removing quite a bit depending on how many items your project has. But that checkbox will be very helpful if you are providing updates for your project, or if you're rolling back to a previous version of a project. You may want to ensure that all items are removed before you import. Although you can overwrite existing items as well when you import a project. So try to give a lot of flexibility there for the end user. There's also this option here, pause notification system. So if I were to import a project, that directory watch project, my email one, or data download, they're all interacting with FME Server's notification service. Now, while I'm maybe shortly after I import the project, my intention is to go through, verify some parameters. Maybe I want to test it first before I actually have it live. So the pause notification system during the import will pause your topics from being triggered, so that you have that chance to give a last check for your items. So we have a FME Server project file in that FME Data 27 folder. and let's investigate how we can import that project. So I'm just here on my projects page here on FME Server. And I'm going to import. We'll choose to import from upload. We don't need to worry about overriding existing items for this because we haven't dealt with any of these components yet. Pause notification system, that's optional here for us to check or not. I'm going to leave it checked as it is by default. And we'll import from, we can choose either resource location on FME server, or we can choose to upload from our file system. So that's what I'll do here. So click upload file. So the project is located in C, FME data 2017. Resources. Code smells workshop. Now I gotta say I don't know the backstory to that one. Best practice analysis.fs project. So very quickly, that project was imported. It is just a small solution, an FME server solution there. We get that process is now complete. In FME Server 2017, we felt it is important to be a little bit more transparent with log files. So both on the projects page and the backup and restore, you'll now see this view log. I highly recommend that for every export, import of a project or FME server backup, that you view the log afterwards, because this will open a log which has always been accessible through FME server's resources. But importantly, if there's any errors in our migration operation, we're going to see these identified right here. So of course, for large errors, you will get a notification in the actual web interface. You'll probably see a pop-up in the top right. But we have seen instances where there are other errors that we are unable to report here. So if you do see anything here that maybe indicates the migration was unsuccessful, then you would obviously want to redo the backup or redo the export. You actually notice that it does bring me to this backup and restore page. So that's also where you can access the log at any time. You just click on backup and restore, and then to the log here. So projects and the backup and restore for FME server, the entire package, they both operate on the same. All right, so we imported a project, so let's check it out. This is best practice analysis. So it's a project to analyze workspaces for best practice purposes. And you'll see that the owner is Mark Ireland. That's because if we come in here, we see that this project actually does import at the same time a user. So Mark stamped his seal of approval on this project here, and now we know that all these solutions were created by him. So we see it has a repository where we probably are storing a workspace. And then we have a notification system set up. So we have a publication here, a couple subscriptions, a few topics to manage the communication. And as well, we have a web connection. So as I mentioned, fairly early, probably on Monday, in the first session, web connections allow us to share our user credentials in a very secure and safe way. So this connection is for one of the Google Gmail accounts that we have set up here at Safe Software. Just by sharing the connection, you don't have the actual credentials, login, password, all that, but you do have the ability now to connect to that service in a very secure manner. So this project is designed to analyze any workspace, just give you some tips on if you are achieving a best practice with your workspace. So we do have FME Desktop certification available, and I don't think that they run this workspace against your workspace itself, but this probably could give you some tips if you're looking to hone your FME skills here. So how to get this project to actually work is we're going to send an email directly to our installations of FME Server. So I'm going to open up my Gmail account again here. So in the event that you didn't have a public IP or you're not working on one of these training machines, you can just watch along here. So I'll write a new message, and the email address that we're sending it to is best practice, and then at our host name. So this is listed in these training steps here, in step 5 here. So that's best practice at, and then we're going to replace the XXX with the IP address. And again, we can get that IP address. There's a link here called your computer DNS name. If you haven't set up a default for your web browser, it might just appear as a generic icon. I can get my public host name from that link, and I'll just paste that in here. So this is going to be my best practice. Here is a workspace. Let's send one of the workspaces from this training course and see if it is up to snuff. So I'm just going to come in here, FME Data 2017 workspaces. Let's choose, what's a good one here? Probably one of these complete workspaces. How about real-time exercise 5 complete? So I'm going to send that to FME Server. And then the idea here is that I'm going to kick off a workspace, and that workspace will use the FME Workspace Reader, which is a new format, if you will. And I guess based on some conditions, tell you if your workspace is a example of best practices. So I'm just going to monitor that topic here. So we'll have incoming workspace. So this is probably the topic that's associated with the email publication, and that's of course easy for me to tell by the topic name. And then we have this outgoing workspace connected to the email subscription that's going to send me an email back. So I'm going to send this in right now. So there we have, using the SMTP publisher, we instantly receive an email and the workspace processed, and there's that outgoing workspace triggered. So now you see I have an email back to FMEShapeProcessing@gmail.com. What this workspace does is it actually takes the from address on the incoming email and has probably an FME Server email generator transformer to turn that around into the to fields. So now I've received an email, best practice report, here we go. So you can see we have some summary information at the top here. We also are reporting the path where we save that workspace. That, of course, is that system temp email attachments folder. So it looks like it passed on the build, and then we also have a variety of other things here. So we got dings for no bookmarks, no annotations. Looks like we have a lot of passes here. Contains an automatically published source dataset parameter. So that's, I had mentioned, when you add a reader or writer, we do automatically create a published user parameter for the source and destination datasets. So this is just a reminder. Oh, you might not need it. Anyway, you can play around with this with your FME server installation yourself. You can even, of course, take this project and put it on your own installations of FME Server. You can investigate the workspace. You can edit things to see to your liking. This is likely using HTML port generator, it looks like to me. You can see I don't know too much about this project, but I don't need to. I just get a project from somewhere. Someone tells me, hey, I got this great solution. I import it into my FME server, and then it just works. I just have to download the workspace. Right, so that is, in a nutshell, how to import, and you can see a solution can just work on your own installation. I'm going to show you one thing here too that's listed in the training manual in this exercise. So we imported this Mark I user with this project, and you can see by default they have FME super user, FME author, and FME admin roles assigned to them. Of course, this is what Mark would have done on his own instance of FME server. But hey, maybe you don't want this user here. Maybe you're like, oh no, it's a security flaw or something. So you can come in here, remove the user, and then watch this here. So I imported this project with a whole bunch of items. They all belong to this Mark I user. If I try and remove Mark I, well, it recognizes that, hey, there's a bunch of items on FME server that belong to him. Who's going to get that ownership? So I have the option to select myself here. And then now when I look at my notifications here, I can see that the topic, for example, here is now owned by myself. And if I go to my project here, then that user is also removed from the project automatically. If I had done this the reverse way and just removed the user from the project, then that wouldn't have removed it from my server. So remember, if you're removing individual items from here, you're just removing it from this project bucket itself. You actually have to go to the proper page in FME server to remove it. So I should have promised a short and sweet day today. That's all the content we have planned for you. So we just had that quick, short, just shy of half hour going over FME server projects. If anyone would like to ask any questions regarding any of the material we went over, or even some items maybe we didn't cover that in FME server you were hoping to learn more about, and we're happy to answer that live right now for you. Well, if anyone's typing in a question there, I'm just going to continue on with the wrap up here. So we do have few Q&A questions for FME server projects, and I think that these are valuable to kind of test yourself with, or at least view this page here, as projects are a new item with FME server, and we do anticipate that they will become popular as a useful resource, that way to containerize FME server solutions.